I will let each presenter introduce themselves more fully at the start of their session. So we can go ahead and get started with our first speaker today, which is Nancy Furlow, who will be talking about resource info to consider, including maps, geology, and aerial photos. So Nancy, you can go ahead and take it away.
All right, good morning all. I am Nancy Furlow. I am the State Resource Conservationist for the great state of Connecticut. And I've been doing this longer than I care to think about, but I'm here today to teach you and give you a dump of some of the things I know when you start going out in the field and start looking at planning and implementation for your producers. We're looking at the 9 steps of conservation planning, and these are the steps that we're focusing on with this particular presentation. Identify problems and opportunities, inventory resources, and analyze resource data. So, for resource concerns, what's the problem? So, I'm going to wing through a couple of pictures here quickly, showing you some problems. So, this could be soil erosion, could be manure. This could be a big problem. What you're seeing here is this is a tillage radish, and note the rather interesting growth pattern of it. So what's the concern there? We've got here some gully erosion. First of all, what's the problem? Can you define it? Can you measure it? Is it safe? Is it consistent? And it's consensus that this is actually a problem. So we're going to go through a couple of things about resource concerns and planning criteria, and this is where you find them. So this is where the resource concern list and all the planning criteria is. This is brand new, based on all the updated resource concerns for CART and Conservation Desktop. And all of this information is located in Section 3 of the Field Office Technical Guide. So in this document, you'll find your resource concern. You'll find, based upon the objective, based on the land use, what the tools are that you're looking at, what the planning criteria is. So this is what you want to plan to. And so the top one here is for crop, and the bottom one here is for other associated land, forest, farmstead, other ag lands. Note that the tools are different and the planning criteria is different. So we move to another resource concern. This is nutrients transported to groundwater. This is for all the land uses, different planning criteria, different tools. So this document is where you find all of this information. Again, you'll find in Section 3 of the Field Office Technical Guide. So here we have a lovely pasture, and your basic resource concern here, or one of them, is soil erosion, cheat, and rill. So the definition is detachment and transport of soil particles caused by rainfall, melting snow, or irrigation. The erosion rate needs to be less than T, and the site needs to be stable without visible signs of erosion. That's what you're planning to. And here are the tools that you're using: the Russell 2, the integrated erosion tool, and your visual inspection. Here's another issue. Soil erosion, ephemeral gully, and classic gully. So again, definition of ephemeral and classic gullies. What your objective is to stabilize actively eroding areas. And your field measurements and observations, you go out there and you measure your gullies, how deep, how wide, how long. That tells you how much erosion you have, and your object is to stabilize that. Here is another resource concern right along here. This is bank erosion for streams, shorelines, or water conveyance channels. So erosion resulting from poor land management practices, storm events, wave action, rain, ice, wind, runoff, loss of vegetation, et cetera, et cetera. So your objective is that your banks are stable with normal stream building processes, and your SVAP, Stream Visual Assessment Protocol, is greater than 5, and your pasture condition score is greater than 4. So your SVAP and your pasture condition score. So here's that tillage radius with this bend in it. That would be from soil compaction. So this is from management-induced soil compaction. And that can be sometimes known as a plow pan or a hard pan. You're looking, you take out your penetrometer to look at where your compaction is, and you want your compaction managed to meet your client's production and management objectives. So at some point in time, you want to take a look at that and make sure that your penetrometer is going in easier. All right, moving right along. Here we have a lovely pasture, and in said lovely pasture, we have some ponding issues. So another resource concern is ponding and flooding, seasonal high water tables, and seeps. We want to reduce the risk to natural resource degradation caused by flooding or ponding, water tables, or seeps. We need to manage it to the client's objectives. Another thing, though, is note state and federal regulations and policies on high water tables, ponding, and flooding. There may be some local permits you need to get. Federal regulations, you could run into some things from the Army Corps, the EPA. So note these things very carefully as you're dealing with these. Here we are back to this pasture again. Nutrients, another resource concern for this pasture could be nutrients transported to surface water. If they're stored or concentrated or applied and they're transported to surface waters, it can degrade the water quality. So you're supposed to discuss appropriate application amounts and practices to minimize the impact to water. So you're looking at nutrient balances, your client input, your pasture condition score, and client observations. Lovely, pretty picture. Back to the same pasture, and different pasture. As you can tell, one set of this pasture has been rotated out. And one of the things that you could be looking at here is plant productivity and health. You're looking for fertility, management, plants adapted to the site, plants that negatively impact your productivity or vigor. And what you want to see are that plants are adapted to the site, that you have a good pasture condition score, that you're meeting your client's goals for their cropping. And the way you measure that is through your crop yield, your inventory plots and transects, your crop tolerance tables. All of those are things that you use to measure this resource concern. And one last look at this lovely pasture. You could also be looking at terrestrial habitat for wildlife and invertebrates. So you're looking at quality, quantity, and connectivity of all the things wildlife, food, cover, space, shelter, and water. And if it's inadequate to meet the requirements of your identified species, then you need to take a look at that. What you have as tools to help you with that is your Wildlife Habitat Evaluation Guides, known as a WEG. And some states have species-specific assessment tools. It could be an NRCS-specific tool, or it could be a state wildlife agency tool. So one of the things that I'm going to go through now, once you've identified your resources, you need to start thinking about how you're going to go out and look at them on a farm. So using an animal waste system as an example, because it comes up with a lot of complicated resource concerns, you could use vegetables, you could use regular cropping systems, any of the above, but I just was using animal waste systems because it can be complicated and lots of things that you need to look at. Another thing is I also, at one point in time in my career, was the manure queen. So animal waste is second nature to me. I stole this from Pennsylvania. Thanks, Pete. So an overview of doing your total resource inventory and evaluation is you need to start thinking about doing it as a team, especially for ag waste. So your team involves the decision maker, your planners, your engineers, and you may have state agencies involved, districts. There's all sorts of other partners that could be involved in this. So first question you need to ask is why we were invited out to the property. What are your decision makers' objectives? And then you need to develop and collect a sufficient data set that you can start developing alternatives for. So your sources of information, if you have a current conservation plan, if you have a current nutrient management plan, if your state requires, there could be an odor plan. Has there been any previous site visit reports? In Connecticut anyway, a lot of people have been visited over and over and over again. So there should be information in the old report. Are there any conservation assistance notes? Can you discuss it with other people who might have been out to the site? Is there site topographic maps? Are there site aerial photographs? And your best source of information is your decision maker. That's the person that works day to day on this farm. They know everything that you're looking at. So check your files, look for hard copies, look for digital. Look at the conservation plan map. Look at any aerial photos you have that may be more recent than the conservation plan map. You can see a lot of things from an air photo. Look at the topography map. Is it steep? Is it flat? Is it got ponds? Does it have a stream down the middle of it? Is there a major school right over the side of your site? All of these things might have impact on your discussions with the decision maker. So again, for your topography, is it steep or flat? Look at your soils map. What are your soils? What are your limitations on some of your soils? Some of them are shallow to bedrock. Some of them are steep. Some of them are flat. Some of them have ponding. Some of them indicate karst topography. All of these. You may have to go out and look at soil tests, soil borings, depending upon what you're looking at. What's your geology in the area? Do you have limestone? This is Pennsylvania. They have all sorts of fun things. Connecticut, I have limestone, and I have mostly schists and gneisses. Talk to someone who knows the site. Has other workers in your office been out there? Other agency staff, have they been out there? The landowner. So, how does the landowner operate? A lot of them are delighted to talk to somebody with how they do. And one of the things that you should look at is the entire year cycle of the farm. So when do they plant? When do they have calves or lambs? When do they put them on pasture? When do they take them off pasture? When do they harvest their crops? What do they do in the winter with their animals? That sort of thing. Next thing you should do is you should educate yourself, especially if you're unfamiliar with the type of operation you're going out to do. I once had to do a duck operation, And I want to tell you, I know nothing about ducks, so I had to learn all about ducks. And by the way, at the time, the Ag Waste Management Field Handbook knew nothing about ducks either. So I think that now covers ducks. Look at the Field Office Technical Guide, look up your appropriate standards or other chapters in the Ag Waste Management Field Handbook. So when you go out, the first thing you need to do is identify the decision maker or decision makers. This is very important that you get everybody on that farm involved. I can't tell you how many times I've gone out and you're talking with the person that everybody is sure is the face of the operation, and they're not necessarily the person who's making the final decision. So be sure you know everybody who's making the final decisions on this. I once worked with a religious organization who everybody in that organization was a decision maker. They all worked on consensus. And let me tell you, it takes a while when you're working on consensus with 30 people. Is there 3 people? Is there 2 people? Is there 1 person? You need to make sure you have everybody involved in this when you're looking at this. So one of the important things is walking over the whole site, not just the barnyard, but the whole site. Look at the pastures, look at the laneways, look at the barns, look at the manure storage structure, look at the piles of manure if they don't have a manure storage structure. Do they take their manure and pile it someplace else? So look at that. Look at the resource concerns and find out the objectives of the decision makers. What type of operations do you have? Turkeys, goats, cattle, ducks, chickens, llamas, alpacas, emus. I've seen all sorts of things. Watch out for llamas and watch out for emus. They can be nasty. Make sure when you're out wandering around in the fields with the decision maker, you know where the bull is or bulls are, because they can be fun. I once spent a lovely time wandering around somebody's farm with a goat horn in my hand, because the minute you turned your back on this goat, it boofed you in the butt. Look at the size of your operation. Is it a small operation, medium-sized operation, or is it a really big operation? How much land do you have to cover? 50 acres, 500 acres? Look at the location. Is it right on the road? Is it right in somebody's backyard, or is it far away from everybody? Is it in an urban setting or a rural setting? Very important. What is your adjacent land use? If you have a chicken operation next to an elementary school, you have to be a lot more careful with wind direction and odor than you do if you have a chicken operation way in the back 40 surrounded by forest. What's your future growth in the area? I've been around long enough that some of the fields I went out and did HEL determinations are now malls and golf courses. And certainly a lot of subdivisions. Where is that future growth? What's the zoning? If it's all zoned 1 acre lots next to your 500-acre farm, you may have neighbors in the future that you're going to have to think about. And does the town, the state, require any setbacks? Sorry, for those of you in New York and Pennsylvania, does your county require setbacks? We don't really have county government in Connecticut. Okay, so also another thing you need to think about is the climate. And this affects the length of your storage operations. It may affect how you handle your manure. We've been having little rain, but when it does come, it comes in 1 inch or 2 inches in 20 minutes. So that may affect your storage. It may affect how you handle your manure. Your climate could vary around the state. So if you have an area that's drier versus an area that's wetter, this works mostly in the large states, it may affect how you're dealing with it. And your rainfall rates can vary. If you're along the coast, might be a different rainfall rate than up in the hills. Look at your crops. So your crop scheduling will need to determine how you manage your manure applications. If you want to put it on your corn, generally you're putting manure on your corn ground long before you're planting. If you're putting it on hay ground, you may put your manure after your first or second cut. Now, if you have an existing nutrient management plan, either by us or by the state, cropping may already be determined in that nutrient management plan, as is your nutrient management and application times. Another thing is that if there's not enough corn ground or hay ground to put all the manure on, you may need to export or compost and get rid of it some other way. You have a pasture system. Your pasture system may impact how you size your manure storage and how you utilize it. You may be putting on your manure after you've rotated your cows through a pasture. You may not be putting manure on a pasture at all because the cows are already spreading it for you. If you put your cows out for 90 days on pasture, your manure structure size may not be as big. Or if you're still in the barn for 6 months, your manure storage size may be exactly as big as it is. Also, the pasture system may impact the best management practices that you're proposing. So another thing you've got to do is you've got to evaluate your access to your pasture. How are the cows getting out there? Are they walking 1.5 miles to the furthest pasture, or are all the pastures close? That can affect how you're doing your systems. Do you have labor available, or does the producer have labor available? Is it just the owner and the family? Is there hired help? Do they depend on seasonal help? Depending upon some of the cropping systems, there may be seasonal help. One of the things that can be done with some of these best management practices is you can design them to reduce labor. If you put down specific paths to go out to the pasture, you're not chasing cows all over the pasture to move them from pasture to pasture. If you put in a manure storage structure that can be pumped out into a large tanker truck and you can spread from there, that can reduce some of your labor. Manure transfer equipment. How is the manure getting from the back end of the cow to your storage structure? So do you have a scraper system? Do you have a below ground system? Do you have the old tire scraper system? So that, and a lot of this will depend upon how you can get to your manure and to your waste transfer system. So what's there? Is it functioning? Is it functioning well? What are they planning on in the future? And some people use custom haulers. So you need to account for the fact that you've got to get the manure someplace where the haulers can pick it up. How do you unload or load and apply the manure? So what you're looking at here is a lot of big tanks and a lot of spreading of liquid manure. However, if you have more solid manure, you're looking at a different set of equipment. So when you're out there, look at the things that indicate levels of management. So if your buildings aren't kept up, if your equipment's outside versus being inside, that can indicate how well some of these things are going to be managed. And you've got to take into account the level of management, which also can account for the level of labor that's available. So if you have the edges of buildings are all chewed up by machinery, you're going to have to account for the fact in some of your designs that somebody might not be that good at driving around with the machine. Once built a big wall and a waste storage facility for a buck wall that somebody said, oh my God, why are you building this? This could hold back the Titanic. And just as that happened, the teenage son comes around the corner with the front end loader and bashes right into another wall. And I said, that's why we build the wall the way we do. So you might have to put in more fail-safes if you've got a poor manager versus an excellent manager. And one other thing to note is that managers change. So what might be an excellent manager right now might be a poorer manager in the future. So you look at the housing. Are they on bedded packs? That's a different type of manure than here they are in a freestall with sand bedding, where this is a flush system. For those of you who've never seen a water flush manure system. So the bedding here with a freestall barn is mostly chopped hay, could be some sawdust, could be chopped straw, some form of that, could be manure solids. That is handled very differently than the flush water here, where this is a sand bedding system. If you're dealing with sand, you have a much different set of equipment needs than you do if you're dealing with chopped straw or sawdust. Here's some more animal housing, some more, this is a gutter cleaner with these ladies, probably could be sand, I don't know, hard to tell. This one is ladies on sand. This looks like a manure scrape system. Hard to tell what system this is. This is a bedded pack system. Again, various types of housing that you need to look at. Travel routes. How's the milk truck get in there? This can affect how you site your practices. How do they fill their silos? How do they haul their manure? How do they get their feed equipment in there? How do they move their critters? So do they take their golf cart out and move their critters down the laneway, or do they run after them, or do they just open the gate and the cows go where they will? All of these travel routes need to be taken into account when you're looking at how you're siting your practices. One other thing, when you're going to visit in the winter, I always figure out if the milk truck can get there, I can get there too. So find out how the milk truck gets in, and that may be how you get into the farm. Okay, odor resources. So are there neighbor complaints? That's a big one we have to account for seriously if we're dealing with any sort of structure that contains manure. Are there fly issues? Flies is like the second biggest complaint after odors, and you can hear this from the towns as well. Are there odors from manure application? I can tell you for sure, as I drive down a couple of roads in Connecticut, when somebody's spreading their manure. Another issue is improper animal mortality. There's people who bank on the back 40 method, which is they take their mortality out to the back edge of the field, and they depend on the coyotes and the skunks and the raccoons to get rid of them. However, that can really stink up a place if the critters haven't done their job quickly. So, do they have an odor management plan? There are places that require an odor management plan, so be careful about that. More complaints, dust from driveways, dust from harvesting. Some people have these large lots that they call dry lots, where the cows hang around, and they're totally denuded, so they're not really a pasture, so there can be dust issues. We're having a lot of dust issues in Connecticut right now because we're in the middle of a drought. Another resource concern that you can think about looking at is energy. As you know, we have a cap to plan for energy, and you can recommend some that they get a cap, conservation activity plan for energy, to take a look at some of the things, high electricity bills, if they don't have the proper lighting, if they don't have the variable speed drives on their pumps. If there's no plate cooler on the milk line, a plate cooler is a very effective thing that cools off the milk before it gets into the bulk tank and saves on electricity. If they have dirty ventilation fans, this can be in any sort of facility from a greenhouse to a barn. If they have high fuel bills, if they're not using reduced tillage, if they're drying their grain with an inefficient dryer, if they're pumping water to an inefficient irrigation system, could also be heating bills due to improper insulation, any of those things. All right, another thing you need to take a look at. So once you've looked at the farm, so what is your laws and regulations? Does your state, your town, your township, your county require a plan? Are there CAFO, confined animal feeding operations, or confined animal operation regulations? Is there an odor management plan required? Are there zoning ordinances that people need to think about? Does your nutrient management plan need to be phosphorus-based? Your phosphorus-based nutrient management plan is very different than a nitrogen-based nutrient management plan. In Connecticut, we're phosphorus-based. Do they need a conservation plan? For the most part, for our practices and our programs, they need a conservation plan. Or if they're doing anything with manure, they need a nutrient management plan. Is there a need for a non-point, I forget what that means. That's a water quality permit or an erosion and sediment control plan. If you're doing a lot of construction work, you may need to consider erosion and sediment control. And in Connecticut, a lot of our towns, if you're opening up more than an acre, require erosion and sediment control plan. Again, are there setbacks that are required by your town, state, or county? Does it have to be 500 feet from a well? Does it have to be 500 feet from a property line? Is it 10 feet from the property line? You got to take a look at your setbacks.
Nancy, we had a question come in.
Okay, go.
Would you like me to? Okay. This person, it's a couple of questions wrapped in one. What is the usual way that NRCS staff find out about complaints? Do people call the NRCS office as a rule? Can you rely on the ag producer to tell you about the complaints? When you hear complaints, can NRCS reach out to the farmer, or do you have to wait for the latter to contact NRCS?
Okay. About complaints, you can hear complaints from the farmer. A lot of times, if you listen carefully, they'll say, oh, this neighbor hates that when I spread manure or whatever. A lot of them have heard the complaints. In Connecticut, the complaints from the neighbors, we rarely hear them because most of the time they go to the State Department of Environmental Protection first, or the State Department of Agriculture. And if you're good enough in including all of these people in your planning, then they will often come to you and say, we're getting a complaint about these people. One of the things that we have heard in the past is our State Deep will say, you have a complaint against you. We recommend that you go to NRCS to help you address these issues. That's mostly with manure. A lot of times, odor complaints are with the town. You may see it in local town papers, that sort of thing. Say the last two questions again.
Do people call the, oh no, sorry. Can you rely on the ag producer to tell you about the complaints? And when you hear complaints, can NRCS reach out to the farmer? Or do you have to wait for the farmer to contact NRCS?
Okay. They can come to us with complaints. If you're working with the farmer, you can bring up the fact that you've heard complaints. Most of the time, the farmers will reluctantly say that, yes, they do have complaints. Normally, if they're trying to work with you on their project, they are trying to deal with some of the complaints to make their neighbors happier, to make their lives easier. And we are not required to go out, and especially if it's a cold call to a farmer that you haven't worked with before or your office hasn't worked with before, we don't have any regulatory authority to go out and try and talk with the farmer about their complaints. If they come into the office and they're looking for HL, you can say, you know, we can assist you with certain things if you so desire, but all our programs are voluntary. Hopefully that resolved some of those questions.
And Nancy, do you think it might be an okay idea to go out to the neighbor's site and recommend like maybe some windbreaks so that that breaks up scents or whatever they might be having? Like there might be conservation practices on their side of the fence that they can implement.
That is true. And I always suggest to people that, especially if they're doing manure storage and other assorted things in their barnyards, that a windrow or fence row planting is a wonderful thing, because oftentimes if you can't see it, you can't smell it. There are times when it doesn't matter whether you see it or not, you can still smell it, and provided that they're eligible landowners, we can certainly work with the neighboring landowners on windbreaks or some sort of tree planting.
I think that covers it.
All right. That's why I was saying citing these practices is very, very, very important to try and avoid some of these complaints. Okay, moving right along here. Another thing you need to consider is utilities, both below ground, this is a gas line, and above ground, some power lines. One of the things you have to watch with power lines is sometimes the farmer will have dropped it down from this pole and it will go underground to various things. Call before you dig. I can't stress how important that is. However, they won't necessarily go in through the entire barnyard. You need to make sure you know where the utilities are. I have had the misfortune of talking with a farmer and saying, where are your utilities? And we went along with the spray paint and we painted where they said that they had buried the utilities. And we were very careful to design and plan around where these utilities were. We carefully spray painted them on before the contractor goes, and lo and behold, 2 shovels full with a monster backhoe, and we're pulling the electricity out of the barn because it wasn't where they said it was. That is not exciting, I do have to tell you that. It gets a little sparkly for a little bit, but all sorts of people get upset when that happens. So be careful with your utilities. Water quality issues. Are there water quality issues? One of the things that you need to do, especially for CAFOs, is you need to prevent off-site discharge for the 25-year, 24-hour storm event. You need to make sure that you're protecting your streams and lakes and ponds and wells. A lot of setbacks have to do with wells. So you got to look at your watershed. Requires additional features, so it looks like we have a ford crossing here. It might be nice if they actually put fence to keep your cows in the ford crossing rather than have them cross wherever they want to. So you got to look at all your water quality issues. Okay, your landscape resources. This is again getting into that neighbor issues. What's the view? It's very important that you know what the view from your neighbors are, because if your neighbors are up the hill from your farm, often the case, and they're overlooking your operation, the operation, you need to know where to site things, and you need to start thinking about things like visual breaks. You've got to know where the prevailing winds are coming from. That's a lot of your odor issues, is where your prevailing winds are from. If you can site stuff so that it's not blowing for the bulk of the time into your neighbor's yards, that's a wonderful thing. Look at your existing tree lines. Can you use them? Can you beef them up? Can you add more trees, more shrubs, some things so that you don't have the view and you can break up some of the odors? Expansion and flexibility. I have been around long enough that the people I originally worked with back in the 90s have expanded 2 or 3 times. So talk with people. What are their future animal numbers? What do they look like within 10 years? Is there space for barn expansion? Is there space in another farm that they're going to put more animals on? Is there space to expand their feed storage? Is there space to expand their manure storage? Are they going to need to look at satellite manure storages? I have one operation that's just their entire barnyard is in this little notch in somebody else's property. They have no room to expand whatsoever, and it's really hampering their operations. They've been told for years that they really ought to consider, as they start building more infrastructure, moving it to another part of the farm where they have more land. What routes do the equipment take? What routes do the animal take? What route does the stormwater take? There are probably a lot of other consultants that may be involved in this. They may have contacted the extension. They may have contacted local builders. They may have contacted some of their crop consultants. They may have contacted some local engineers. There's all sorts of people that you need to consider when you're dealing with your producers. So once you've been out and you've done all your looking at the operation, you've talked with the decision makers, you've talked with the people, you've looked at the neighbors, you've looked at everything, write it down. If it's just in your brain, you have a problem. So you take notes in the field, you take pictures where you have permission, you take a look at all the resource concerns, you make this lovely document, and you document it all on the various forms that your state has. A lot of states have inventory worksheets, cost estimate worksheets, practice worksheets. Document all the various details for everything that you're going to need. It will help you when you start talking with the producer about alternatives. So you put it all together. You're identifying the resource concerns. You're collecting all the site data you can so you can do your alternatives. Please note that all the resource concerns you identify may not necessarily match the objectives and concerns of the decision maker, and you need to note that as well, because they're going to start focusing on the things that they want to do, their objectives and their concerns. So we need to make sure that we know what resource concerns they're looking at and how we can help them with that, and maybe, just maybe, we can push some of the other resource concerns that they may not be that concerned about into our practices. So, and I think I'm about on time. So are there any more questions?
Okay, we have one that came in. Oh, no, it was just thank you. All right, so I guess we can move on. Eric Schwab is going to be our next presenter. He's going to talk about Intro to Cropland Conservation and Basic Plant Biology. So, Eric, if you would like to share your slides and get started.
Okay, I'm Eric Schwab. I'm the state agronomist in Ohio. I've been in Ohio about 5 or 6 years. Previous to that, I was the state agronomist in Alabama, again for about 5 years. Before that, I worked for the Agricultural Research Service as an agronomist for about 10 years at the National Soil Dynamics Lab, developing conservation tillage systems for the farmers of the Southeast. So whenever I do kind of introduction to cropland or talk with new planters, I feel like I have to have a Hugh Hammett Bennett quote. As you all know, Hugh Hammett Bennett is kind of the father of soil conservation. and really found that NRCS and the soil conservation districts. It amazes to me, we're talking 60 years from his death. Oftentimes when I get a quote from him, it ends up being towards the end of his life, kind of after he retired. He did a series of lectures at a university in North Carolina. I can't remember which university. But it's really fascinating to me that, 60 years later, 60-plus years later, you can find things that he was talking about then that are so applicable to us today. It seems like, things have changed so much, and they have, but yet some of the struggles that planners had then, we still do. So today, I wanted for us to consider this quote, and coming from the last presentation, I think was a good example. The treatment of the land not only has to fit the land, but it has to fit the farmer as well, especially on cropland planning. We sometimes get in today's world this idea that there's really just one way to do it, and there's no options, and all plans will look the same. Well, if that's the case, then we really don't need planners, but we need planners. That's why we're doing all this training and putting this effort, because it's not the best system for the land. It's the best system for the land and the farmer as well. And not all farmers are going to be willing to manage things the same way. So I kind of wanted to start off today with that thought in mind as I go through, common practices, and even you might even get the presentation, the perspective from my presentation that there's one way to do it, but there really isn't. We as planners have to set a series of practices that not only address the needs of the land, but address the producer as well. So with that in mind, when we think about doing planning on cropland, we design a set of practices to address resource concerns. The common resource concerns that we're going to see on cropland, of course, are soil erosion, sheet and rill erosion, ephemeral gully erosion, classic gully erosion, the soil health resource concerns, or the soil quality resource concerns, compaction, organic matter depletion, soil organisms, habitat loss, aggregate instability. In addition, especially coming from Ohio and really all over the Northeast with Chesapeake Bay, water quality on cropland is a huge concern, whether that's nutrients transported to surface and groundwater, pesticides transported to surface and groundwater, pathogens associated with manure application, and of course sediment transport to surface water. In addition to those primary resource concerns that we'll probably almost always see and want to make sure we're addressing, there are other secondary resource concerns that may be a particular problem on the piece of land you're planning on, or maybe a particular problem based on the producer's objectives, or maybe even neighbors' complaints like we heard in the last presentation. And those are plant productivity and health, plant pest pressure, the air quality concerns, whether it's particulate matter, greenhouse gases, odors, or the wildlife, terrestrial habitat, in energy. So we're going to design for cropland, we're going to design a series of practices. And as I hope you all know, all the practices are in section 4 of the Field Office Technical Guide and the Conservation Practices and Supporting Documents. The great thing about planning a system, and hopefully all of you have been exposed to some level with the soil health initiative, soil health excitement, I guess I should say. And one of the things in that soil health information that we always talk about is the soil health principles. And really, if we think and keep in mind the soil health principles, we will do a pretty good job of planning on cropland. So the soil health principles are, armor the soil. We have to protect the soil from that raindrop coming down from the sky. With all that energy that is going to detach the soil particles from the soil and start the erosion process. We want to minimize soil disturbance, not only, again, to keep that soil armored, but to create a habitat for that diverse microbial activity that we need and we want to encourage, again, for aggregate stability and a lot of nutrient cycling. We want to have a diversity in crops, again, not only for kind of a nutrient uptake, balanced nutrient removal, but again, for that diverse, high-quality microbial life, they need diversity in crops. And we want to maintain a living root year-round, again, for the benefit of the microbes below the soil surface. So if we keep those principles in mind, like I said, we'll do a pretty good job of planning. So I'm going to go through a series of practices, talk about, the primary resource concerns that they address, kind of a definition and how we would look at it. So the first practice I'm going to talk about is conservation crop rotation, 328. It's the planting of a sequence of crops on the same ground over a period of time. It's the rotation. Generally, we're going to plan crop rotation to address sheet and rill erosion, ephemeral gully erosion, water quality nutrients, and nutrients, transport to surface and groundwater, plant productivity and health, and plant pest pressure. So if we think about rotations here in Ohio, the vast majority of the acres are corn, soybeans, or corn, soybeans, wheat. There's also some pretty poor rotations in Ohio that don't provide those principles in terms of protecting the soil, whether that's, soybeans, corn, or, you can have a lot of variation within rotation. So what I was saying again about crop rotation, there's a vast difference in the crop rotations that we plan in terms of the level of treatment. For example, a corn and soybean rotation is vastly different than maybe a corn, wheat, 3 or 4 years of hay, kind of a sod-based rotation. So we wanted to plan rotations that not only meet the needs of the producers, but try to have the highest level of protection. You can scroll on to the next slide. The next practice I'm going to talk about is residue and tillage management, no-till, 329. This limits the disturbance and the orientation of crop and plant residue on the soil surface year-round. The criteria for this standard is what they call a soil tillage intensity rating, a stir rating of 20 or less, which is a calculation we primarily do in Russell 2. It's a very limited amount of equipment, soil interaction, and no full-width tillage. Full-width tillage is defined as any one tillage implement that engages the soil on 1/3 of the area or more. So some strip tillage implements will meet this standard if they do not disturb more than 1/3 of the area. So we plan this practice to address sheet and rill erosion, ephemeral gully compaction, organic matter depletion, soil organism habitat, and aggregate instability, in addition to nutrients transported to surface water and, of course, energy in terms of energy associated with tillage. So go on to the next slide, please. So the next practice we're going to talk about is the other residue and tillage management standard, and it's called reduced tillage. Again, this manages the amount and orientation of crop and plant residue on the soil surface year-round. So the criteria for this practice is a stir under 60, which is a lot more tillage, and you are allowed to do full-width tillage. So again, it causes there's a need for a Russell 2 calculation, and the resource concerns we address with this they're really exactly the same: sheet and rill erosion, ephemeral gully compaction. Clearly, there's vast differences in the level of protection that these two standards, the no-till and the reduced tillage, provides to the soil surface. So with that, go on to the next slide. The next practice I'm going to talk about is cover crops, 340. A cover crop is defined as a grass, legume, or a forbs, or a mixture of those planted for seasonal and vegetative cover. So these aren't planted as crops, but these are crops that we're going to grow and return to the soil surface in most cases. We plan those, again, to address the soil resource concerns, the erosion, sheet and rill erosion, ephemeral gully erosion, and the soil quality, soil health, resource concerns of compaction, organic matter, soil organism, habitat loss, and aggregate instability, along with the nutrients transported to the surface, water, and sediment, and energy. If somebody wants to, now that I can see the chat, tell me how cover crops, as I go on to the next slide, reduces energy, let me know. You can go on to the next slide, and we'll talk a little bit more about cover crops. Cover crops are pretty exciting things to plan in some ways. There's a lot of things to consider. So you have to understand when this seasonal coverage is needed, whether that's a cool versus warm season, because that will vastly change the species you plant. So cool season plants generally grow good in the fall and in the spring. Cool season plants are like cereal grains, the wheat, the rye, some of the clovers, crimson clovers, versus warm season crops or cover crops like sorghum, sudan, sun hemp are primarily our warm season crops. So you have to understand, generally in the Northeast, we grow a lot of warm season crops. Corn, soybeans are all warm season crops, and we're looking for cool season cover crops. That's when we need to provide that seasonal cover. So understanding when the cover crop grows versus when you need that seasonal cover. Right along those same lines as the planting dates. We recommend cover crops are planted between 2 dates or a date range. So the date range has to line up with when the crops are harvested. So unless you maybe interseed, like in this picture here, that high boy interseeding. Rates become very important because we're going to communicate a certain rate to be planted, and seed quality. Through the years, we've seen vast differences in seed quality. Sometimes cover crops are sold with seed coatings that will drastically require more products to be planted. And herbicide carryover these days has become a real concern when planting cover crops, in that the herbicides that they're using on their crops may, the residual herbicides, the herbicides that last a long time in the soil, may affect the establishment of the cover crops. So I asked the question, how does cover crops reduce energy? How might you plan cover crops to reduce energy? And someone said, by reducing the number of passes by the tractor needed for weed control. That's a really good point. Oftentimes, cover crops can grow a lot of biomass and can really serve as a great mulch to reduce post-planting, after you plant, emerging weeds, and can reduce the amount of passes by the tractor, which is energy. But also we need to think about the energy needed to make those herbicides. Any chemical process like that takes a lot of energy to make herbicides. So if we're reducing the amount of herbicides we're using, that is an energy savings. Also, if we are using legume cover crops, we reduce the nitrogen rate. And again, nitrogen manufacturing is a high energy process. So cover crops have many great uses, address a lot of resource concerns. We need to think about all of them. They might not be at the top of the producer's mind, such as energy and cover crops, but they can be used. So we can advance on to the next slide, please. The next practice I'm going to talk about is nutrient management, 590. This is the managing the rate, source, placement and timing of the plant nutrients and soil amendments while reducing the environmental impact. Nutrient management, the nutrient management standard is based on what they call the 4 R's of nutrient management, which is a method promoted by the nutrient industry. It's called the right rate, the right source, the right placement, and the right timing of nutrients. We're going to plan this practice to address water quality, nutrients, transport it to both surface and groundwater, and pathogens and other chemicals from those manure applications. Also for plant productivity and health. There's also air quality benefits, greenhouse gases and objectionable odors, and energy. Again, if we're using less fertilizer, or maybe the right amount of fertilizer, which might be less than what they're currently using, there will be energy saving. So scroll on to the next slide. So the nutrient management standard is based basically on a nutrient budget. I think here in the Northeast, we're always going to be doing soil samples. The soil tests phosphorus and potassium are correlated with yield response that will generate recommendations for P and K, phosphorus and potassium, and those applications will be based on those soil samples. Nitrogen varies from state to state, but most time in the eastern part of the United States, the nitrogen recommendation will not be based on a soil sample, but maybe a yield goal or a economic analysis of the cost of nitrogen versus the corn. So in addition, we need to think that 590, or remember 590 is for all nutrients, not only commercial fertilizer, but it also includes manures. Oftentimes when working, it was a really great, refreshing to hear that presentation about working with animal feeding operations. I always, when working with animal feeding operations, encourage people to think about they're not only livestock producers, but they're fertilizer manufacturers, and they need to treat that manure like it's a product that they want to protect and sell, and not or sell or utilize themselves, and not just dispose of on the land. So there's a question about, in the 590, referring to the current standard, does this apply to the new standard? The national 590 was updated about a year ago. Many states, including Ohio, are in the process of updating, and that we in Ohio will have a new 590 in fiscal year 21. What I provided was just real general information. Everything I said applies to the new 590. So you probably will, I know in Ohio we'll be doing more 590 training in the near future to explain the new requirements. But everything I provided was general, would apply to both. So we can continue on. Pest management conservation systems 595. So that one is a hard one for me to say because this is a relatively new standard. It was released the same time as the 590. I have the new name now that we brought this up. It used to be Integrated Pest Management, Integrated Pest Management, but now it's Pest Management Conservation Systems. Has a new name. The system that combines an integrated pest management, or IPM, decision-making process to address pest and the environmental impacts. Again, we're going to be planning this practice to address water quality, pesticides, plant productivity and health, plant pest pressure, and some of the air quality resource concerns. If we can scroll on to the next slide. The pest management systems, conservation system standard is based on a PAMS approach, and PAM stands for the Prevention, Avoidance, Monitoring, and then suppression of pest. So when we think about the PAMS approach to pest, we want to really encourage a plan where the producer prevents and avoids pests, maybe by using certain varieties that are resistant to pests, maybe by cleaning equipment to reduce the transport of resistant weeds, things that they do so they won't have the pest, or if they do have the pest, it won't cause a problem to their crop. The next step would be for that producer to monitor, whether they're dealing with resistant weeds. Maybe they check their fields twice a month or every week to see if they have any weed escapes before they apply the pesticide. It's not, the 595 standard is not a standard for just applying pesticides. It's not a standard for not applying pesticides. It is a standard that encourages producers to have a plan and to use pesticides when needed. In addition to that, to address water quality, we're going to run a tool to evaluate the risks to water quality and mitigate those risks. So that's the Pest Management Conservation Systems 595 standard. So we can scroll on to the next slide, please. Filter strips. A filter strip is a strip of herbaceous vegetation that removes contaminant from overland flow. So what we need to remember about a filter strip, so if it's going to remove contaminants from an overland flow, has to be on the downhill side of the field. So we wouldn't put a filter strip on the upper side of a field, if that makes sense. Again, we're going to be addressing the water quality resource concerns, because that filter strip, as the water goes through the filter strip, it will slow it down. Maybe some of the sediment will be caught in the filter strip. There'll be some more additional infiltration. It has specific vegetative planting requirements. We want to ensure or try to get sheet flow, not concentrated flow, across the filter strip. So a filter strip, again, is an edge of field practice that we'll use on Cropland to help with water quality. So we can go on to the next slide. Grass waterways. A grass waterway is a graded channel that was established with the vegetation or the grass, like it says, that it conveys water in a non-erosive velocity to a stable outlet. So again, we're going to be addressing classic gully and nutrients transported to surface water and the other water quality benefits. If we scroll on to the next slide, grass waterway is one of the practices when we think about Hugh Hammett Bennett, and when he was a soil scientist young in his USDA career, he was tromping around the Piedmont of North Carolina and South Carolina, and what he was seeing was this, concentrated flow erosion. And he was concerned not only was that destroying that local producer's ability to make a living on the land, but it was destroying the country as a greater good to produce the products and the food that we need. So when we plan a grass waterway, when we address these concentrated flow, these gullies, this goes back to our founding. This is what we do. Oftentimes when you're maybe riding in the truck with an experienced planner and you say, hey, tell me some things that you've done in your past career that you are most proud of, oftentimes it will be to address these concentrated flow erosions. These are things that we should take great pride in my opinion. Go on to the next slide. Terraces. Terraces are an earthen embankment or a ridge with a channel constructed across the field slope. So they will be on what we call the contour. So they'll have equal elevation, almost equal elevation. There's a little bit of a slope to channel the water to the outlet. Again, we're going to be addressing the sheet and rill erosion, classic gully and ferruminal gully erosion, and the nutrients transported to water. These terraces are engineered structures that sometimes can either be grassed, like in the lower picture, or sometimes we can plant right through them. Again, they're to channel that water to the edge of the field to reduce that slope length to slow the water down the hill to reduce erosion. So if we can scroll on to the next slide. Contour farming. Contour farming is like a terrace. We're going to plant or do the tillage on the contour of similar slope. You can see from the picture, and the picture is not exactly, it is contour farming, but it's contour strip cropping also. But you can see how those strips are all curvy because they're following the contour. Again, this will slow the water down to some extent and reduce sheet and rill erosion and the sediment and nutrients from the water quality degradation. So you can see how we follow this, the contour of the field. This practice can be a challenge depending on your site-specific kind of slope condition. This is an extreme example, and it's a real challenge nowadays with equipment size because the equipment is so large and it's hard to turn the edge of the field, and producers sometimes don't have that flexibility with the size of equipment. We can scroll on to the next slide. I think we might be there, done. So despite our challenges, I think we got done a little fast. Maybe I was going too fast, but hopefully that was an introduction to planning on a cropland. And again, as we think about our training and as you guys have more training and more experience, just remember, what Hugh Hammett Bennett says, we're not necessarily trying to design the best system for that land. We're trying to decide the best system for the land that will work for the producer, because our ultimate goal is to get adoption. And if it doesn't work for the producer, then we won't get adoption. So we have to work within what the producer is willing to do, what we can sell that producer on doing. So with that,
Okay.
So we have a question about which I don't know if you can see that, have the longest soil residual times. So herbicides, when it comes to how they might affect cover crops, it is a real challenge. Within USDA policy, we have to be very careful when we talk about herbicides. We should probably not be recommending or not recommending certain herbicides just because that's not necessarily what we do. Within policy, if you're a certified crop advisor, you can recommend herbicides. We can definitely refer to extension publications, other documents that make herbicide recommendations. But we as NRCS have to be somewhat careful because that's something that we don't want to take responsibility. In addition to that, we as USDA employees have to be very careful that we cannot recommend a herbicide what they call off-label. So if it's not specifically spelled out in the label, then we can't recommend it. That makes it extra challenging with cover crops. Each herbicides have what they call a plant back restrictions, which limits what crops you can plant back after you make the application of a herbicide. When it comes to cover crops and just the nature of herbicides and to get things on the label, it has to have, properly replicated experiments where they looked at specific crops. And because of the diversity of cover crops, often the cover crops we use aren't listed on specific herbicides, so we have to follow the setback rules for all other crops, which will often be way in excess of what is needed in terms of what we could plant back. So I would encourage you to work with your local extension folks. There's some really good information. Penn State has some really good information on herbicide plant back restrictions with cover crops that may or may not follow the label. The University of Missouri has some really good information, and I would encourage you to kind of develop that relationship with your local extension folks and doing outreach type meetings. Get a local, extension person, maybe a retailer, to talk about herbicides and how residual there are, because it is an ever-changing thing, and even me as an agronomist really has trouble keeping up with the trade names of herbicides, and as they change through the years, I won't really even comment. I won't even answer the question, I guess is what I'm saying.
through
Okay,
that
so
last
there's a question. Yeah, I'm reading the question about the percent of no tillage in Ohio and how it's changed in my career. No-till definitely has changed throughout the years, and it's maybe not always changed in what we would say is a positive way. In Ohio, currently, probably 60% of the soybeans are no-tilled, maybe 70% of the soybeans are no-tilled. The wheat is probably a little bit lower than that, and the corn is probably somewhere less than 50%. In Ohio, it's really a complicated, I think, issue in terms of timing. There's a lot of tillage that is done to dry out soils to make it a wider window to plant, which there's some ways you can do that within a no-till system, but we have a lot what we call rotational tillage, where it'll be a few years of no-till and then they'll come in with a full width tillage. How has that changed in my career? Well, I've worked in a couple of different states. A long time ago when I was in Alabama and working with cotton, actually, cotton went from about, less than 5% no-tilled to 70 to 80% no-tilled in the Deep South, and it all had to do with the herbicide traits being added to cotton. That's happened with all the crops. Before the herbicide traits were added, weed management was a real concern. The Roundup Ready traits added to the crops really changed that. We're seeing that, in my opinion, kind of flip back a little bit because of the herbicide-resistant weeds. Here in Ohio, we have mare's tail, herbicide-resistant mare's tail throughout the state. There's a little scattering of Palmer pigweed. On the western side of the state, there's getting to be more and more giant ragweed that's either resistant or tolerant. It's tolerant to several different herbicides. So with that being said, in a tillage system where you can incorporate some residual herbicides makes weed management a little easier. So we're seeing more and more pressure, in my opinion, to going back to some full width tillage in some circumstances. So with that, I don't know if there's any more questions. I don't know. I'm not too bad on time.
I'm not seeing any more questions. So I'd like to thank Eric for his presentation. We're going to let Karen Hoffman kick it off with Intro to Pasture Management and Foraging Animal Types. So Karen, if you will.
Great. Thanks, Rachel. It's nice to be here this morning, and this is an interesting opportunity. I don't do a lot of online presentations, so bear with me. I'm used to being able to make eye contact with people. But first I wanted to introduce myself. I'm here in New York, and I've been with NRCS for just over 23 years. I was originally hired as an animal scientist back when I started my career, and my background is actually in dairy grazing nutrition, and so I was hired to work with dairy producers that were converting over to managed grazing or prescribed grazing. And over the years, I've also worked with a lot of livestock producers as well. And 2 years ago, our state grazing specialist retired, and I was assigned those responsibilities because it made sense. I was already working with a lot of grazing and pretty familiar with the methods and the standards and those kinds of things. So anyway, that's a little bit about me. On a personal note, I have a small multi-species grazing farm. So we have sheep and goats and some beef cattle, and I get to practice what I preach, and I also get to experiment with ideas that I learn out in the field from producers. So my first presentation today is on Introduction to Pasture Management. And really, it really is an introductory level. I know from looking at who's participating today that some of you have done some grazing planning and you're familiar with pasture management. but hopefully I will provide some other information for you that you haven't heard before. I'm also going to talk about different types of animals and some of their grazing behaviors. I know that a lot of times people are hired and they have more of an environmental science background or forestry background, and maybe not familiar with the different types of animals and the terms that are used with them. So hopefully this will give you a good foundation as you go out and work in the field with livestock and dairy producers. So the first thing I wanted to talk about, and the other thing I wanted to say too is, like, some of these slides I actually got from a colleague in Pennsylvania, Susan Perry. She's the state grassland conservationist down there, and she's done a similar presentation, and I really liked some of her slides, so I've incorporated them into this. So I just wanted to acknowledge her for that. So starting off, what is pasture? And I think what happens is a lot of times when we think of pasture, we think of the swamp, we think of, the poor soil types, we think of, a dry lot system where animals are just thrown out in the pasture and whatever they can get to eat, they get to eat. And, if it becomes overgrazed, oh well, or if they, leave a lot of stuff behind because it's all weeds or, things they don't like, then that's okay too. But with prescribed grazing, what we're really looking at is improved land and looking at having really good forage species out there for the livestock to eat. And we're managing those plants to improve the quality of the forage that's available to the animals as well as the yield. And instead of using a tractor and a haybine and a baler or a chopper to obtain the feed for the animals, we're letting the animals go out there and get it themselves, which has a lot of advantages both for the animals and for the economics on the farm, because anytime you can reduce the use of machinery and equipment, you're saving the producers some money. So this is not a pasture that I would say is being managed for quality. This is grass that has all been, grown to the point where it's headed out, it's putting out its seeds. There's not a lot of green material there. And really what our animals are looking for is green vegetation that's high in quality. Now, this is green, but there really isn't any yield there because these cows have overgrazed it to the point where, they might get a few little mouthfuls here and there, but it's not going to be a substantial enough quantity to, help them with their milk production. So when we're talking about managed grazing or prescribed grazing, we're really looking at something that looks like this. It's green, it's actively growing, there's a nice mix of grass and clover, and the animals can get enough to eat to support their production needs. One of the challenges that happens with pasture is that those plants are alive and actively growing, and they do change in the amount and the quality every single day. And so when we're planning a grazing system, we need to take into account that we're trying to capture the grass when it's at its best quality, and not necessarily its highest yield, but at a good level of yield, so that every mouthful that the animals take is as much forage as they can actually get with every single bite. And so what we're really looking at is there's 3 phases of pasture growth. In the early spring, when it's young and it's just beginning to grow, it's really high quality when it's 2, 4, or 6 inches tall, but there really isn't enough quantity there for the animals to meet their dry matter intake requirements. When we get to the second phase, in the middle of this slide, where it's leafy and somewhat mature, that is really the optimum time for grazing. And the reason for that is that it's still very good quality. It's high in protein and it's high in energy, and it can help to meet the livestock's nutritional requirements. And it's also leafy enough that the animals are interested in eating it, because once it gets into that phase 3 of stemmy and over mature, there's a lot of fiber in those plants. The plants lay down a lot of the 3 components of fiber are cellulose, hemicellulose, and lignin. And the more mature those plants become, the more lignified they are. And the more lignified they are, the less interested the animals are going to be in eating it. And it's also less digestible, so they can't get as much nutritional value out of it when it gets into that semi-over mature phase. Now, in the spring, it can go from that leafy immature phase, if you look at the bottom, to that semi and over mature phase pretty quickly, because most of our grasses are cool season and they grow very rapidly in the spring when it's cool and when there's plenty of moisture available. So from 0 to 25, you can go from 0 to 16, 18, 20 inches tall. And so the objective of grazing management is to plan ahead and design a system where we're always turning animals into the grass when it's in that second phase, that leafy mature phase. In the summer, if you again look at the bottom of this slide, it takes longer to go from 0 to phase 3 of the stemmy and over mature stuff. It can take up to 50 days to get that kind of growth, simply because the grass grows slower when it's hotter and drier. And so to get to that leafy mature phase where we want it to be, instead of only taking 15 days like it does in the spring, it's going to take about 30 days in the middle of the summer. And so our planning for that needs to take into account that the amount of time it takes for our pastures to regrow is going to be almost double in the summertime what it was in the spring. So hopefully that makes some sense for those of you that are watching. So in our planning, we're really trying to find the right balance between the forage supply in that phase 2 and the amount of forage demand that we have coming from the livestock. And when we're looking at planning a system, we may have an aerial photo such as this where we've got a field that's already pasture, but maybe it's not been managed, or maybe it's only been slightly managed. And then we have a lot of crop fields close to the barn, close to the headquarters. And we may want to look at converting some of those crop fields to pasture because they're close to the barn. It's easy for the animals to get there, and it may be a better soil type that could be very productive in a grazing system, and it would be easy to establish, fencing, maybe some laneways, animal trails and walkways to get the animals out there and back to the barn if it's a dairy, and also to get a water system developed to provide water out in the pasture so that the animals don't have to come back to the barn. So when we're looking at a farm, this may be what we're presented with. And so we have to sort of think creatively about how to lay out a system so that we can divide this up into individual paddocks where the animals would graze through at different times of the grazing season. So using the rotational stocking method, which is what prescribed grazing primarily focuses on, although we do also plan continuous grazing, but it's a little less desirable to do continuous stocking. So I'm just going to go through the rotational stocking method here with you this morning. So in the spring and early summer, as I mentioned, we have a high forage supply. And so the idea with our planning is that we would establish paddocks where in the spring the animals would graze about half of the system and then the other half of the system would be cut first for hay or silage. And thinking about the fact that we have a 15-day rest period in the spring, if we had 5 paddocks that had enough grass for 3 days, 5 paddocks, 3 days each, gives you a 15-day cycle. And then in the summer, when we get to 30 days of rest before the paddocks are ready to be grazed again, we could have 3 big paddocks that would be easy to get machinery and equipment into to take that first cutting off. And then each of those paddocks would be sized for 5 days of grazing, maybe using temporary fence to subdivide it even further. And that way you can add in that extra acreage that we need in the summer to get to a 30-day rest period. Now, keep in mind that really to give that 15-day rest or that 30-day rest, you're probably going to have an extra paddock because the paddock that they're in currently doesn't start resting until they get moved out of it. So you may actually end up having 6 paddocks in the spring and more in the summer as well, so that you have that full 30-day rest period. The other thing to consider is that as we have more periods of drought, I know a lot of the Northeast right now is suffering through drought, and we've had the same situation on our farm. You might end up having to have a longer rest period or having a plan for the animals to go somewhere else during a dry period, such as in the barn, or to have a sacrificed area where they're fed hay for a period of time until, the drought conditions are, have gone away. We've gotten some rain, the grass has regrown. So in your planning for grazing, you also have to have a contingency plan for what is going to happen for drought. There may be periods where it's too wet in the spring to put animals on pasture. So all of those contingencies should be accounted for in a grazing plan. Some other management decisions to think about in planning grazing is, normally we recommend a shorter grazing period of 1 to 3 days because it can help to increase the amount of grass that the animals can eat. And this is simply because there's less of it that becomes trampled by them walking around on it or fouled with manure or urine. Most animals will not graze where another animal has dropped manure. So you, by moving them more frequently, you're spreading the manure around, you're reducing the amount of trampling, so they'll actually eat more of the grass that's available in that paddock. I know that, a lot of times we're dealing with farmers that maybe work a full-time off-farm job, and so they want to move their animals less frequently. They want to do it on the weekends. And, the thing you need to account for is that there's going to be a lot more waste in those pastures when they're moved less frequently, and so you would probably need to account for that in your planning. In terms of fencing, you really want to match the type of fence with the type of animal. If you have sheep and goats, you're going to want more strands, or you may want woven wire on the exterior. If you have cattle, you may only need to have 1 or 2 strands to keep them in because they're pretty respectful of high tensile electrified fencing. And the other thing to think about is predator control, those small ruminants. If you've got a producer that has a lot of coyotes or other types of predators, maybe like bobcats, when those lambs are out on pasture, or the kids, if they have goats, they can be pretty susceptible to predation. So picking the right type of fence based on the type of animal can be really important from that perspective as well. So resource concerns are really where we should start when we're looking at practices to help implement a grazing system. We get a lot of people that call up and say, I want to sign up for that fencing program. And really what they're just looking for is a perimeter fence because they want to get some animals, or they have some animals and they want to, they just want to do something a little bit different. But as we all know, we need to be addressing resource concerns with NRCS, especially program dollars. So things we would look at are, an overgrazed pasture where there may be nutrient loading, or, there's a lot of soil erosion because there's nothing really growing in that location. And this would be especially true if it's near a water course or a water body, or if there's, if there's groundwater concerns because of this kind of concentration of nutrients around this round bale feeder in the photo on the right. Other resource concerns, animals in the water bodies are never a good thing. I always look at this picture on the top left and wonder, what dairy farmer would want their cows wading around in green algae, because there's a lot of animal health concerns with that. But anyway, stream crossings, trying to get animals to only cross a stream in one location and develop it to the point where it's not causing soil erosion is a resource concern. There's some pastures where you're going to end up with gullies because it's been overgrazed for so long that the water has just run downhill and created the gullies. And that's another resource concern that we can address with good grazing management. What does it take to develop a pasture? Well, you need fence, you need laneways, and you need water. So there's all kinds of different types of fencing. I mentioned that a little bit earlier, that you should match your fencing type to your animal type. There's high tensile. Some horse producers like using what you see in that top left-hand picture on the right-hand side, which is the wide electrified ribbon. That works really well, especially for animals that need the visibility of the fence. There's also high tensile. There's temporary fence, which you can see in the bottom left-hand corner. A lot of producers will electrify this ribbon or this tape that has small pieces of wire that runs through a mesh, and for the most part, cattle respect that if it has a good enough charge on it, that they'll stay on the right side of that fence. I can tell you from personal experience that if an animal is a little spooky or stubborn, or your tape isn't charged enough, then they will go through it. I had a steer that was in the woods for several months because he went through the tape and didn't come back until he was lured back. So anyway, and then there's combinations. The bottom right-hand picture is a high tensile fence, but it has some temporary gate material, which helps with animal movement and makes it easier than using like a big metal gate. You can just use 2 strands of a temporary gate material that's electrified, and usually the animals will also respect that. Of course, anytime you electrify a fence, you want to have a warning sign on it so that, especially if you're along a road or a property line, to make sure that other people know that the fence is electrified and to reduce liability issues. Just some pictures of some animal trails and walkways. This is really important if you have a dairy and the cows are going to and from the barn twice a day. You want to have a good laneway that's, crowned, or that has geotextile material, or both, to, help get the water off. It makes it much easier to get animals in and out. You have a good laneway, and they're not having to pick their way through stones and mudslides and those kinds of things. So the most important part of the laneway is where it's closest to the barn because that gets the most use. And then as you go further out into the grazing system, the laneway can be a little less developed. So anyway, and then the last thing is water. There's lots of ways to get water to livestock on pasture. This upper left-hand corner photo shows a permanent concrete tank. I'm pretty sure that that's a gravity-fed tank, and that works well in a lot of cases. There's also the portable Rubbermaid tanks that some producers use. The nice thing with these is that if you have places where the water trough can be plugged into a water line, you can reduce the impact on the pasture by moving that trough every time the animals come to a paddock, so that you may have an area that gets denuded once. When they come back 15 or 30 days later, you put it in a different location. That helps to regenerate the grass where it was the first time, and also helps to spread out the nutrients. In the bottom right, or the bottom left, you can also see that you can put a more permanent system in place where you protect the trough, and you would probably do a heavy use area around that water trough so that you're protecting the resources. Again, anywhere that you're going to be crossing a stream, you want to do a stream crossing. Limit the amount of area that the animals have access to the stream. Protect the stream banks. It also helps to protect water quality. One of the key things with a stream crossing is that if the animals are going to be grazing on one side of the stream, you want to make sure that there's a gate to keep them out of the stream crossing, because that would defeat the purpose of the stream crossing if you're trying to keep nutrients out of the water. If they have access to the stream crossing, they will go in there to drink and stand in the water and drop their manure in the water. So making sure that your stream crossings are closed off to animals when they're not in use is a really good idea. And then just a little bit about forage species selection. We're really looking to have a diverse pasture species mix of grasses and legumes. You can see the upper left-hand photo. That's a new seeding that was done with a no-till drill. And hopefully over time with good management, that will fill in and you'll have less gaps between the plants, and you'll have legumes that come in and help to support the grass with its nitrogen-fixing abilities. The picture on the top right is actually one of my pastures. This is a mix of 2 or 3 different grasses. You can see there's some clover in there. There's also some crown vetch. We had a little bit of a cover crop mix that I mixed in with our grass seed mix, and I broadcasted on an area that had been a little bit abused, and got this nice mix of different types of forages. And the bottom one is just, showing another grass clover combination. So we're really looking at grass and legumes. There's a lot of forbs that livestock will eat as well, such as plantain and dandelion. And so if those are in a pasture, that's not a bad thing. And then the last thing we want to look at is soil fertility. And the photo on the left is from the Adirondacks. And there's a lot of places where you see trees growing on rocks, but in a pasture, we really recommend getting a soil test done and then applying the nutrients that are needed to help those plants grow better. Soil pH is probably one of the most important things to look at in terms of getting a pasture to improve. If you've got a pH over 6, your pasture should do relatively well, and that will also help those plants to find the other nutrients that they need in the soil. So just to summarize quickly, with pasture planning and management, And again, this was just a really quick introduction. There's a lot more to planning a pasture system, but you're really looking to balance your forage supply and your forage demand. And one of the things I didn't mention is that most states have some sort of an Excel spreadsheet or a worksheet, you can do on paper that helps you to estimate what the forage supply will be from the pasture and then what the demand will be from the livestock. And that can help to establish how many acres you need for a system. It can tell you what your paddock sizes should be based upon how long the animals are going to be in a paddock and all of those kinds of things. So if you haven't learned how to use one of those yet, you can always contact your state grazing specialist, and they usually have something like that can be used. The other thing with pasture planning and management is you make sure that those plants have time to rest, to regrow to that, 8 to 12 inches, that phase 2 of the optimum forage height. Rotating the animals around is another key part of it. And then we're also looking to address resource concerns with our practices, getting animals out of water, reducing nutrient issues, all of those kinds of things. And to do that, we need that infrastructure of fence, water, and laneways. And lastly, there's some other benefits from grazing. There's benefits to wildlife. There's benefits to pollinators. There's benefits to soil health. And without going into too much of that, I'll just tell you that I've been really amazed on our farm how many different species of birds we have. We have bobolinks that nest in our pastures. We have all different kinds of pollinators. I've really been enjoying seeing different types of bees, and we've got a lot of monarchs right now. So it really is true that grazing has multiple benefits. So with that, I'm going to switch to my other presentation. Are there any questions at this point?
There are none in the queue, but if people have questions, please use the chat forum and I will monitor that.
Okay, great. So I just want to talk a little bit about our foraging animal types. As I said at the beginning, I know a lot of times that people come into the agency that don't necessarily come from a farm background and may not have worked a lot with livestock producers to know all the different types of animals and the terms. So I just thought I would do a very quick overview of that. And full disclosure, I went to college to be an animal science major, and I had never been on a farm. I was interested in being a veterinarian, and so I was one of those people that started off not really knowing a lot about farm animals or livestock production, and so I understand, where people sometimes don't have the knowledge that they need. So anyway, just quickly, grazing is really impacted by animal behavior because different types of animals graze differently, have different preferences for what they're grazing. Some of that has to do with differences in anatomy, and some of it has to do with differences in nutritional requirements. We have different types of foraging animals. We have ruminants and we have non-ruminants, and I'm going to talk a little bit about those differences here in a minute. But basically our ruminants are cattle, sheep, and goats. Non-ruminants are horses, swine, and poultry. And then species like llamas and alpacas are camelids. They're sort of a hybrid between the ruminants and the non-ruminants. And I'm not going to talk much about the camelids here, but if you are looking for information about them, most of our state grazing specialists have had some experience with alpacas and llamas. So the ruminants have a really interesting digestive system. They have what's called a four-chambered stomach, which includes the rumen, the reticulum, the omasum, and the abomasum. And by having this four-chambered stomach, they can digest feeds that have higher fiber content that monogastrics like us can't utilize. And let me just back up here for a second. So the non-ruminants are horses, swine, and poultry. And horses do have the ability to eat forages similar to cattle and sheep and goats, but there is one big difference, which I'll get into here in a minute. Swine and poultry, we do see them on pasture a lot, but they're not really ruminants. So anyway, going back to this. So the rumen, the reticulum, the omasum, and the abomasum, this is a diagram. And the rumen is really a large fermentation vat. It has millions, billions of bacteria, protozoa, and fungi that help the animal to break down those fibrous parts of the plant. And the rumen is constantly in motion, so the food comes in, the rumen moves, it mixes everything together. It's got a fluid part, it's got a solid part. So the rumen moving like that helps to mix the liquids and the solids, and that is what helps with the fermentation by all of those microorganisms that are in there. The reticulum is a little pouch at the front of the rumen. That's where the cud comes from. All of our ruminant animals chew their cuds. So solids that can't be broken down by the bacteria end up in the reticulum. The reticulum squeezes, pushes the cud back up to the mouth, where the animal chews it a little bit more, breaks it down into smaller particles, and then it comes back down into the rumen and can be digested. The omasum and the abomasum are the next two areas. Liquid gets pulled out in the omasum. It looks like if you were to open it up, it looks like a book that you would open up to the binding. It's got a lot of different layers in it, and all of that surface area helps to absorb the liquids. And then the abomasum is more like our stomach. It has enzymes and acids that help to finalize the breakdown of the feed as it goes through their digestive system. So it's really a fascinating, to me at least, as a nutritionist, it's a fascinating system for breaking down feeds and converting it into, milk or meat. Now, horses have some ability, as I said, to ferment forages, which is why they can eat hay and grass. They are hindgut fermenters. They have a cecum that is, quite a bit larger than what you would find in most animals or even in people. And so they can also digest a lot of the fibrous feeds in their cecum, which actually comes after their stomach. So food goes into their stomach first, and then those fibrous particles kind of hang out in the cecum for a while and get fermented, and then continue on into the rest of the digestive system. Swine and poultry also have cecum, but they don't have a very significant fermentation in the cecum, which is why, anybody that is using swine and poultry on pasture are also supplementing with the more traditional grain that those animals will eat. And swine will also eat a lot of food scraps, so, corn husks from your corn on the cob or other types of food waste, they're able to eat those. So in terms of grazing, there's feeding preferences of different types of animals. Goats, sheep, and cattle will all eat a combination of browse and forbs and grass. Goats prefer the forbs over the grass and legumes. Sheep prefer the legumes and the forbs, legumes more than the forbs and more than grass. can tell you that my sheep will eat a lot of things that I know that the cattle will not eat, especially things like bedstraw and a couple of other plants that very rarely will see cattle eat. And then, of course, cattle prefer grass over legumes and forbs. Now, some of this is based upon the structure of their mouth. So ruminant animals have no upper teeth. They have what is called a dental pad in the front of their mouth, and they have teeth on the bottom. So when they're grazing, what they do is they wrap their tongue around the grass and rip it off with their bottom teeth. This is part of the reason why they don't want to graze that taller, stemmy, mature forage, is because it's more difficult for them to rip a stemmier plant off as compared to a younger, more vegetative plant. Horses, on the other hand, have upper and lower teeth, so they have the ability to graze a lot of plants that, may be more stemmy, but they also can graze things lower to the ground because they have those upper teeth. And that's why you'll typically see in a horse pasture that hasn't been managed, where the grass might only be a half an inch tall, whereas cows and sheep and goats, they tend to leave a little bit more behind because of the way their mouth is different from horses. So cattle really prefer grass that's 6 to 10 inches tall, and they have a hard time meeting their intake requirements when either the grass is too short or the density of that grass is decreased. So if there's a lot of bare ground between plants, it's harder for cattle to get enough to eat in a pasture. So having a nice, thick, dense sward of grass where every mouthful is as big as it can possibly be is really what we're looking for with cattle. Sheep do have a cleft lip on the top, which does allow them to get a little closer to the ground than cattle do, but they use the same method in terms of using their tongue as the cattle do. Now, goats are interesting because they like to browse above their heads, and they will strip the leaves off of all different kinds of brush. This goat in the top right is eating a honeysuckle plant. It's really amazing to see how quickly they can defoliate honeysuckle. They'll eat multifloral rose. They'll eat buckthorn. They'll eat willow. So, they're really a great animal to use if you're trying to eliminate brush. But they also like to eat grass. And what they do is they eat individual leaves off of the plants, and they'll basically pluck, or they'll start at the tip of the plant and work their way down because their lips are a little bit more, I want to say, they're prehensile, which means that they can manipulate their lips a lot more than sheep and goats do, or sheep and cattle do. And then with horses, again, they can get really close to the ground, and they can be really hard on a pasture. So, if you can encourage horse owners to do some management of their pastures, there's a lot of benefit in terms of preserving the resources if you can get them to do that. So just quickly, since I'm getting close to my time limit, so just some of the terminology in terms of the classes of stock. So with cattle, basically you've got calves, yearlings, heifers, bulls, steers, and cows. A calf is from birth. It's a calf from birth until it's about a year old, when it becomes a yearling. And then it's a yearling from 1 to 2 years of age. And they reach maturity at about 2 years of age. They may not be physiologically as big as they're going to get at maturity, but they are considered mature at 2. Now, a heifer is a female that has not had a calf yet. And sometimes you'll hear a producer refer to a first calf heifer And that is basically a young animal that has had her first calf, and it's just a way to designate that she hasn't, become a fully mature female yet. And with beef cattle, you're more likely to run into a steer, which is a castrated male. There are bulls on most beef cattle farms. Dairies tend to use artificial insemination, so the chances of running into a bull may be less, but you should always make sure if you're out in the pasture that you ask if there is a bull, because they can be very dangerous. Okay, with sheep, just quickly, we've got lambs, which are from birth to breeding. You would call a breeding, potentially a lamb that you're going to breed would be called a ewe lamb, or they're a lamb until you harvest them. Everybody harvests their lambs at different ages. Some are quite young, some are closer to almost a year old. A ram is an intact male. Also, be careful if there's a ram on the farm that you're visiting, because they can be dangerous even though they're smaller. And a wether is a castrated male sheep, and a ewe is a female sheep. Goats have kids. They are kids from birth to 1 year. A yearling from 1 year to their first time they kid. The intact males are called bucks. The females are called does. And like with sheep, a wether is a castrated male. And with horses, when they are newborn to 1 year old, they are a foal. If it's a female, they're called a filly, and they are usually referred to as a filly from when they're about 1 to either 3 or 4 years old. A colt is a male up until about 3 or 4 years old. A stallion is a mature male. A gelding is a mature castrated male, and a mare is a mature female. Just quickly, a little bit on multi-species grazing. This can be a great way to optimize your pasture use, because sheep and cattle and goats all have different preferences. Animals tend to graze farther away from their own dung and urine, but they will graze closer to a different animal species' dung and urine. They can be used as management control tool for parasites. Grazing cattle after sheep, especially because sheep are most susceptible to parasites. And you can also have less labor managing and moving them as one group. So basically, understanding the different livestock species can help you with planning your grazing systems. Each one has unique terms, and they also have different production cycles. And if you have the basic understanding of livestock, you can have better communication with producers about their goals and what they're trying to achieve with their grazing system. And that's all I have.
Great. Thank you, Karen. I don't see any questions. Oh, wait, one just came in, but you did get kudos for going through that terminology a moment ago. The first question is, how could you maximize rotational grazing depending on micro elevation changes within a farm? For example, should you graze the lower areas earlier in the spring than the higher areas?
So I would say that you really need to look at where the grass is growing the best and the fastest. And I would expect that a lower elevation pasture would grow maybe a little bit better in the spring, because maybe it's a little bit better drained, or maybe it's a better soil type, and maybe it has gotten temperatures that are more conducive to growing grass. Likewise, there's probably places where a higher elevation pasture will grow better in the spring than a lower elevation one. So you really need to look at that particular microclimate and how the grasses and legumes are showing up first thing in the spring.
That was the only question in the queue here. So okay. I think if there are no more, which I'm not seeing, thank you for your presentation, and we can move on to our 1030 block. Coming up in the 1030 block, we have Debbie Serbain doing map unit design in ESDs, Meredith Albers with soil health, and Dr. Nicholas Bellatani with cultural resources. So let's start it off with Debbie. It looks like you're sharing already. You're way ahead of me.
Okay, well, hello again. This is Debbie Serbain, a state soil scientist for Connecticut and Rhode Island. And today I'm going to talk about soil surveys and ecological site descriptions. So here you have a beautiful piece of property. We're helping landowners plan great conservation practices. And how do you know it'll be a good site? Well, Nancy, Eric, and Karen did a great job of reviewing a lot of the things, resources and questions and things to look for. But we can help you more with that. And there's so many questions that about the site that soils and ESD information can help answer. Questions like, does the area flood? Is it a possible wetland area? Does it have prime or statewide important farmland soils? Possibly what species could do best? And fortunately for you, a soil scientist and ecological site specialist have collected a lot of this data for you to use. So quickly, just so you know that...
If I could just back up for 1 second. We had a question about what does ESD stand for. I think that's ecological site description. Somebody else answered. I just want to confirm.
Yes. So you should know that as part of the National Cooperative Soil Survey, NRCS is the lead agency for mapping, interpreting, and distributing soil data. We have well established from a long period of time standards and protocols that began from the first soil survey conducted in 1899. There was 4 of them back then that started. So NRCS is also the lead for developing ecological site descriptions, or ESDs. So yesterday, Jacob and I talked about the important concept of soils as natural 3-dimensional bodies that form as a result of, remember, the 5 soil forming factors? And we use this concept to develop soil landscape or land formulations to inform us of what soils are most likely present on site. And in knowing this, we can develop soil surveys that you use. And we know where to delineate these boundaries, a lot of times without digging a lot of holes in the ground. Now, we've done a lot of this documentation and collection of information, so you could have these soil surveys, where I'm going to show you soon where you can find them. So we have completed soil survey work in a lot of areas, and on this slide you can see a soil survey map and legend. The soil map shows soil boundaries or polygons labeled with a map unit symbol. And the legend on the left shows the map unit symbol and the map unit name. So I want you to know what a map unit symbol is. It could be letters or numbers with letters, depending on what soil survey you're looking at. And typically they're either state or county. And the map unit name, I want you to know what that is. So for example here, the soil polygon labeled BKB2, that's the map unit symbol, and it has a map unit name of Beddington, Shaley, Silt Loam, 3 to 8% slopes, moderately eroded. So what does this mean? Well, you can hit on the map unit name and we can get more information. So the map unit generally contains a major, or sometimes referred to as a dominant component, with minor components that are considered inclusions. And these minor components are just considered too small in size to be recognized on the soil map. Under the soil map unit description, on the upper right, you'll find the soil map unit symbol again. It's BEB2, and the soil map unit name, again, Beddington is the major component, and it is a series name, and I'll define that further. And it has a shaly silt loam surface texture on 3 to 8% slopes, and this is a eroded phase, meaning that the surface horizon is thinner due to erosion. And the series is mapped on 149,101 acres in Pennsylvania in that series Extent Explorer. So quickly in the chat box, can anyone tell me if this soil is a prime farmland soil, looking at the map unit description?
Somebody says yes.
That's
A few
right.
people say yes.
Okay. You have to read the entire map unit description. It has a lot of good information in there. All right, so I said the word series. Series is a group of soils with similar ranges and characteristics, and it is the lowest level of classification in the Keys to Soil taxonomy. So we classify soils like plants and animals, and to classify them, we use the Keys to Soil taxonomy. So I really want you to become familiar with the soil series in your area, by seeing them in your local soil survey. So go, and I'll show you where you can find those. So if you're lucky, you'll get a soil katina chart or a soil block diagram of your area, and these are really helpful in learning the soils and actually visualizing where they are. And this is a soil block diagram here. So for the most current soil survey information, it's all on Web Soil Survey. And this information is also in CD and used in CART. All previous published soil surveys are great, but they are for historical reference only. I just want you to be aware that when using maps in Web Soil Survey and you're zooming in and you get a warning that reads, warning, soil map may not be valid at this scale, well, you most likely zoomed in too close and the soil map is not accurate at that scale. Why? Because the soil map units and delineations were done at specific scales based on user needs at that time. So these maps are great for general planning purposes, but not for determining Food Security Act wetland compliance, which needs to be done, should be done most times on site, but we can use other maps to determine that off site. So there are a ton of soil reports and data, information, interpretations that you can find on Web Soil Survey. And if you can't find what you're looking for, use the search tool, take time to use it. If all else fails, ask your state soil scientist, but really you need to take the time to learn what's in there. And remember that your farmer most likely knows what is on his or her property, so it's a good idea that you know too. Because if they bring up a series name and you don't know what they're talking about, you might want to go back and quickly bring up your soil web on your iPhone and check that out. So switching gears now to ecological site descriptions, or ESDs. ESDs document the change over time in response to specific processes in nature and management. And they use state and transition models. Like you see here, they define reference and states. They're great for guiding conservation planning activities like restoration or maintenance of sites. So where do you find them? Here you can find them in Edit. Here is one for high floodplain levee. Eventually, all of these will be located in Web Soil Survey. You can see here they are linked to our database. Our soils database is called NASIS. It stands for National Soils Information System. So they'll get linked to components in the soil map unit, and we export them and upload them into Web Soil Survey. So here's some that are actually located in Web Soil Survey under the Soil Data Explorer tab, Ecological Site Assessment, Ecological Sites tabs. And again, you can search for them and play around with Web Soil Survey. Here's a photo of that. It shows photos, a description, various tables. And you can also find ESDs in Soil Web under land classification. So this is just another tool to bring up soil information and then a variety of, not just maps, but other information that's included. So again, you can find all of this data under, you can find soils and ESDs under ePhotog, Web Soil Survey, Edit, Soil Web, and some of it on the USDA NRCS Soils web page. So if you want to learn more about this topic, remember, contact your state soil scientist to learn more about soils and ESDs. There's a lot on the USDA NRCS Soils webpage and on the state soils web pages. Any questions?
I don't see any questions. Somebody did post the Web Soil Survey for Google Earth link.
Yep, you can. Yep, so you can pull your Web Soil Survey onto Google Earth as well too, if you like using Google Earth. All right.
Okay, so does that bring us to our next speaker, Meredith?
Yep,
Meredith, are you on?
So I am. I'm getting my screen shared, and a couple of segues I want to go throw in there. In the chat quickly, who knows when NRCS was founded? What year? Crickets. 33? Oh, you're so close. 1935. And who knows who the founder of it was? Hugh Hammond Bennett. All right, awesome. Now, who knows what Hugh Hammond Bennett's career was before he founded the Soil Conservation Service? A surveyor of what? So Hugh Hammond Bennett actually worked on soil surveys. The National Cooperative Soil Survey that Debbie just talked about was established in 1899. And Hugh Hammond Bennett worked for many years doing soil survey work across the country and internationally, which is part of why when the Dust Bowl happened, he knew what was causing it and how we could fix it, because he had seen soils management across the country in different ways. Another transition I want to do while talking to Karen's or listening to Karen's presentation is there's this great PDF. I'm going to put the link to it in the chat here, where an extension agent in Montana actually did an article saying managing soil health is like managing for rumen health. So if anybody knows more about animals and soil health, or they want to learn more about rumen health and soil health at the same time, there's a nice little article you can read about microbiology populations in both rumen and soil health. I also know that the presentation that you guys got in the slides, they're a little small and hard to read. So I'm going to copy my references into the chat now for everybody so that access those. You can copy that text out and have it easily available for some of the stuff that I mentioned in this presentation. And if you have any questions, just go ahead and type into the chat. I may not see it. I may not catch it right away, but I will definitely copy all those texts out later and compile the questions if we don't have time to go over it, and I can get back to you later. So let's see here. All right, so my name is Meredith Albers. I am a resource soil scientist out of Vermont. I'm originally from Missouri. I used to work for Soil Survey in Iowa and Minnesota, switched over to the planning and conservation resource side in Montana and Utah before finally moving back east, missed the rain. Here we are in Vermont. And soil health is one of the things where we get to do fun, outreach, educational activities So these are some pictures of just some of the outreach and educational events we've done in Vermont. So trying to make it a fun topic. You guys will get out. You'll have fun with producers talking about soil health. Everybody wants to talk to NRCS about soil health. One of the things I want you to remember, though, is managing for soil health is not a new concept. Soil quality booklets were around in the 1990s. Crop rotations, cover crops, no-till, these are things that have been around since the 1950s. I don't know how old this publication was, but because it didn't have a date. But this guy's, mowing down or tilling under a green manure crop. Well, that sure sounds like a soil health practice to me. So quick, anybody want to throw in the chat what you think the date on that photo is if you're a tractor aficionado? No snide remarks because it's from Saskatchewan. So brief outline of what I'm going to try to cover. We'll probably run out of time. Go over what is soil just briefly and what is soil health in relation to that. And then soil biology and the carbon cycle is really when we're managing 1492. That's a good one. Soil biology and the carbon cycle. This is how we're really managing soil health, is using that carbon cycle. Principles of building soil health, and then if there is time, we'll cover some testing and assessing of soil health as well. So what is soil? Debbie and Jacob giving presentations yesterday. Debbie just gave a little recap on mapping. But what is soil in terms of how it's functioning? It provides physical stability and support, right? We walk on it, plants grow on it. Water, it allows it to infiltrate. It also stores it and then supplies it to the plant over time. It's also providing nutrients to the plants. These are some soils all across Vermont, beautiful forest soil on the left there. We've got one that's, maybe lacking in the physical stability and support on the right as that tree is about to toss over. But, in their native habitat, that's a natural part of how that soil forms and functions. But what is soil health? When we talk about soil health, we're focusing on the continued capacity of that soil to function, to provide those functions for the ecosystem that it's sustaining, whether it's plants, animals, humans, trees, agricultural crops. So we're looking at soil health through a different kind of lens. Here's a diagram I've gotten from a couple of different people. It's been reworked a couple of times, but based on the presentation that Debbie and Jacob gave yesterday, that's kind of our left side of this PowerPoint slide. We've got our 5 soil forming factors. Those are all combining to give us our current soil as it exists in the landscape. And then we manage it somehow. Maybe it's in forestry, maybe it's in agriculture, maybe we're harvesting it or burning it or different things. And when we're doing management on the soil, what we're really changing out of those 5 soil forming factors is the organisms that are growing on it. Is it an annual crop? Is it perennial? Is it trees? Is it grasses and legumes? When we change that biology, that's where we're affecting the soil health, altering those organisms. To bring that home, soil health is all about biology. Now, these photos are not from around Vermont. They're not from anywhere in the Northeast. They're from all over the state of Utah. But I wanted to put these in here because when we're talking about soil health, the ability for the soil to develop certain soil health properties that we're assessing and evaluating varies depending on the ecosystem it exists in. So these desert soils in Utah are extremely healthy soils because they're very resilient in their ability to function in their ecosystem, providing all the ecosystem services they provide. They don't have the properties we want for an agricultural system, but that doesn't make them not healthy. So I want to bring that home because as we're working with different types of soils, they're going to have different capacities to become healthy. And when we're aiming for that soil health for agriculture, that may look a little bit different than just the native ecosystem. So this is a diagram of the soil food web. You may have seen it before. I just about guarantee you're going to see it again. Starting with the sun, feeds the plants, organic matter, all these microbes building up to larger trophic levels and bigger animals. When we're managing for soil health, we're really focusing in on the food web at this scale, looking at stuff that's actually living in the soil. This is the new science that we're learning more and more about every day, which is changing our emphasis on these soil health practices. I want to draw some arrows connecting everything back to the organic matter, because that other food web diagram kind of has most things going away from the plants into the microbes, but so many things are fed back into that organic matter pool from the microbes and other organisms that live in the soil. Another point I want to make is that this organic matter pool is about 58% carbon. So we're going to talk about the carbon cycle a little bit too, but just keep that in mind. When we're talking organic matter, we're also talking building carbon. So these are two screen clippings from a video that was narrated by a soil health guru, former NRCS, Ray Archuleta. And the one on the left is got, kind of a cloud of sugar and cells around a root tip, and then each one of these little cylindrical blobules in there are microbes that are swimming around in this cloud of sugary goo around the roots. So they're chewing and feeding on things coming from the roots and secreting things like nitrogen and nutrients that go back to the plant. And the same with the screen clipping on the right of the root hairs all over the root. And the thing I really want to drive home here is the plant is providing sugar to the microbes. The microbes are providing nutrients back to the plant. But nutrients and fertilizer we talk a lot about as plant food, but it's not really plant food. Nutrients, NPK, those kinds of things, they're more like a multivitamin. If the plant can't produce carbon, can't capture it from carbon dioxide in the atmosphere using photosynthesis, the plant doesn't have any food. It'd be like if I'm on a diet and I'm taking all the right multivitamins, but I'm not getting enough calories for the day, I'm not going to survive very long. So we really, for soil health, need to focus on doing what we can so that the plant can capture more of that carbon, because that's the food it needs, and it's the food that it gives to the microbes in the soil to keep that nutrient cycling for all those other nutrients going. Just remember, sugar, it's food, it's carbon, it's moving in this cycle, and that's what's building soil health. This is a screenshot of a great two-page, just a one-page front and back extension publication that Penn State actually put out a while ago, and it's about mycorrhizal fungi in field crops. So another root microbe interaction has to do with these mycorrhizal fungi that actually have this kind of symbiotic relationship with the plant. They extend the plant's rooting network and are able to capture nutrients like phosphorus and bring them to the plant, while the plant is giving the fungi the food source. It's giving the fungi the carbon. And the diagram on the right actually has two pots side by side of oats. The plant on the left has oats that were planted in a soil inoculated with these mycorrhizal fungi, and on the right, it's actually got plants in a soil that did not have any mycorrhizal fungi in it at all. So you can really see the difference in the production level when you have this microbial environment present in the soil. And again, I just want to bring home, the plant is providing carbohydrates to the fungi. That's the source of energy for the fungi. The fungi is grabbing other nutrients to help that plant produce more carbon. Here's another diagram. We're really going to nerd out on some of this. And yes, there's a link to that publication. I don't know if there's a number, but you can have it. It's listed in that resource list. There's actually a consultant in Montana who has it hosted on their website now, because I couldn't find it on the Penn State website anymore. So this diagram has the root, and then the little black lines are that fungal hyphae growing out from that fungi into the soil. You've got the root hairs. They're kind of short and stubby by comparison to the hyphae that can go all over the place. Then you've got soil aggregates that kind of collect in that hyphae. This diagram is from an Ag Research Service publication that talks about glomalin. So the hyphae kind of form a net that help hold together the soil aggregates, But then those hyphae are secreting this chemical called glomalin, and that helps protect the hyphae so that as they're transferring moisture and nutrients to and from the plant, they don't lose it. It doesn't like leach out into the soil. But then they also, as they're producing that, it gets sloughed off into the soil and ends up coating all of these soil aggregates. And this, when I was talking about soil health principles and management isn't new, glomalin was first identified in the early 1990s. A lot of the science and technology we've had to be able to study this is very new. Glomalin.
Meredith,
yeah?
Just to interrupt for a second, somebody was asking if there's a publication number on this, but I do see that you have a website for where they can find this slide. Is that correct?
Yes. So in the links I posted at the top, it says Penn State College of Agricultural Sciences pamphlet, and then there is a North 40 Ag website link that I posted further up in the chat for that publication. So I don't know if it has a number or not, but I know that's where they can grab it.
Thank you.
Sure. So yeah, so glomalin is organic matter, and remember, organic matter is carbon. So when we think of organic matter, we usually picture something like this. We picture leaf litter, we picture peat, humus, broken down, dead plant materials, compost, manure, things that we incorporate with tillage. But 15 to 20% of the organic matter, or organic carbon in undisturbed soils, is actually glomalin that coats these soil particles. And when they were able to identify glomalin, they developed a procedure to make it glow as this bright green material so that you can see it and how it's covering all of those soil aggregates everywhere. So as we're managing for soil organic matter, and we think about, oh, I should add compost, oh, I need to bring in this outside carbon source, a significant portion of the carbon in soils is something that is produced by mycorrhizal fungi, by soil microbes in place in the soil. And in order to have those growing, producing these organic matters that help with soil resilience, we need to have plants growing in the soil. So Jay Fuhrer is a retired NRCS soil health specialist who was a district conservationist for many, many years in Bismarck, North Dakota. And these are screen clippings from a video that he would start some of his presentations with when he was emphasizing the carbon cycle. And it's another one of those links I posted at the beginning of the chat. It's actually a NASA video, and it's a simulation model. They took real air data, carbon dioxide concentration data over the course of a year. This year happens to be 2006. And they made a simulation model so you could see how the concentration of carbon dioxide in the atmosphere fluctuates over the course of a calendar year. And so the upper left-hand corner, we start with January. No color whatsoever is very low concentrations. Red, dark red, even purple is very high concentrations. So you can see that there's a lot of it in the northern hemisphere in January. That's where most people live. That's where most of our industry is. That's where most of our carbon dioxide emissions are produced, and how that builds throughout the winter and even into the spring, where it's looking pretty nasty in May. And then in June, you see how much it diminishes, and in July even more so. In August and even into September, it's almost like there's nothing in the northern hemisphere at all. And the point, people see diagrams like this and they immediately think of climate change and catastrophe. But the point I wanted to do, and Jay always did, was showing this, is look at how critical vegetation is for the carbon cycle. All of that terrestrial vegetation growth really kicks into high gear in June in the northern hemisphere. And it's really going nuts, July and August, even into September and October. We're now in the fall, but you can still see how much carbon dioxide all of those plants have pulled out of the atmosphere, incorporated into their plant matter, and also into the soil. So this is the kind of carbon cycle, you know, when we're talking about managing for soil health, thinking in this big picture term, using plants to capture and grab that carbon and incorporate it. That's what those soil health principles are doing. This is a slide from Don Rajkowski, who was a ARS researcher out of Morris, Minnesota. Great guy, but he's one of the first people to document the loss of carbon due to tillage. And in his presentations, he really talks about utilizing nature, utilizing these practices we can do that are going to minimize carbon loss, so no-till, with practices that will incorporate a lot of carbon into the soil, so things like cover crops. So to get our soil health, to build our sustainability in our systems, we need to be managing to have this soil carbon put into the soil. So 5 principles of soil health. A lot of times you're going to hear 4. Because I've worked out in the West, they have this 5th one that they use sometimes. So we're going to go through these quickly. Minimizing disturbance, increase your diversity, keep it living, keep it covered, and then incorporating livestock. It's not something that is as common here in the East, but it is something they've seen a lot of benefit from in the West. So I wanted to mention it just because you may see it as you learn more about soil health in your career. So when we talk about disturbing less, we're talking about 3 different types of agricultural disturbance, because it's not just tillage. That's obvious. You know, it's ripping up the soil ecosystem. It's getting all this oxygen in there, which promotes breaking down the organic matter, which releases fabulous nutrients, but that's not sustainable, because then we need to fertilize, then we need to add all these things. But we also want to try to minimize chemical disturbances, fertilizer, herbicides, pesticides, because they hijack that soil food web. They drive it into particular directions. It's no longer utilizing the plant to capture all this carbon. Why does the plant need to support a microbial population to bring it nutrients if we're just giving the plant nutrients available? So we had a question about some Asian worms. I don't know specifically for those species. They're definitely causing issues with forests in northern environments, but in agricultural systems, depending on where you are, promoting earthworms is a very beneficial thing. So you do see a lot of earthworm promotion in the soil health documents. Another thing is biological. If we overgraze, that's problematic, because then the plants are too busy trying to replenish their green. They're not providing carbon to the soil and promoting that soil food web. If you have long-term haying, you don't have a whole big diversity of that food web contributing to different ecological niches for the microbes, bringing in different things to spruce up that biology. So when we talk about different types of disturbances, it's not just about physical tillage. Using diversity of plants to add diversity to the soil. Soil biology is diverse, and it needs a diverse diet. You know, not all plants support the mycorrhizal fungi. Only certain ones have that connection. So like a brassica doesn't have that symbiotic relationship with those fungi, but brassicas produce different residues that different microbes might feed on. So it's just like building diversity in any ecosystem. You build resilience. We want to do that with the soil. We want to have diversity in the plants that are grown on top of it as well. Having living roots in the soil as long as possible. So this is that keep it living. The soil food web needs food year-round, or as much of the year as possible. If we have a good snowpack, that soil never freezes, so you still have some biology active even in the wintertime. It just may not be active very much. So we still want to try to have some plants there, some plants possibly growing. So minimizing or eliminating fallow where there's nothing growing, building that organic matter in there. This photo at least one of the people in this photo happens to be on this call. This is of a field of cover crops planted in Vermont last year. It was planted in July because they couldn't get their corn planted because it's a very heavy clay soil, and it was a really cool wet season. So when they couldn't get the corn in on time, they just did a multi-species cover crop planting. And we were out there in the fall. You can see the trees are already turning. The hay fields had already started to go dormant, but these annuals were growing so much, they were so active, they were producing heat. And he said the hay fields were frosting before this cover crop field. And if they got a light snowfall, the snow would melt off the cover crops sooner than it would off of the hay, because those plants are still alive. They're still using all that energy. They're still bringing carbon into the soil and feeding the soil food web. Okay, so the fourth one, keep it covered. This is classic, right? NRCS, we've been talking about residue management, protecting the soil from the impact of rain droplets, from erosion. Now we also bring in temperature extremes. As we're managing for a soil microbial community, we want to keep that soil temperature moderated throughout the season as well. So keeping it covered is another critical, one of the big four soil health principles. And then the fifth one, incorporating livestock where it's practical. And like I said, this is one out west where they've seen a lot of benefit from bringing in those higher trophic levels into these systems. And these two slides are screenshots from a presentation he did, and I have that link posted above in the chat, discussing how they're using them in their carbon cycle, how plants, respond to being grazed. Out in the West, when they had big herds of buffalo that would come through and graze areas really intensive, but then they'd move on and the plants would have a long rest period, that promotes a lot of organic matter accumulation in the soil through that natural plant life cycle. So it's just something I want to throw out there, because you'll see it periodically as you're learning about soil health in other parts of the country. Not something that's been as emphasized in the East, but I just want you to be aware of it. So just as a summary for those soil health planning principles, 1, minimize disturbance. And this is an order of importance, by the way. Most important thing, minimize the disturbance, increase your diversity. Cover crops is a big way we push this, but it's also, doing multi-species, doing crop rotations. Keep something living as long as possible. That's another big point where cover crops come into play, getting that beginning or end of season living going on, and then keeping it covered. Having something growing on it will do it. Having residue, if nothing else, some sort of mulch if you can, and then possibly incorporating livestock if that system allows for it. The goal being you want to create that most favorable habitat for the soil food web to build that soil organic matter. Okay? So do we have any other questions?
There are none in the queue at this time.
Okay.
But feel free to type. Oh, we got one. How do common herbicides like glyphosate impact the mycorrhizae and thus glomalin production? How does long-term haying remove carbon from the soil?
So I do not know how glyphosate impacts mycorrhizae. I apologize for that, but I can do some searching afterwards. And long-term haying is removing carbon from the soil because we're actually removing that plant material from the field. Just like, when we're applying fertilizer to like an annual crop, we do at least the crop removal rate, right? What is the corn we're taking away? What is the silage we're taking away? We need to add that back. So long-term haying, if you're removing that carbon perpetually from the system, there's nothing being put back in. If I'm grazing, there's awesome. Thanks for the lead on the glyphosate question. If you're grazing it, there's carbon coming out the back end of all of those plants. It's not a lot, but it's building that organic matter as well. Yeah, the roots are adding organic matter, but if there's not enough diversity in that hay system, it's not building as much as it could be if you had other diversity in there, if it was grazed periodically, things like that.
Great. That seems to be it for questions at the moment. Thank you for your presentation, Meredith. That was great.
Sure.
Looks like Nicholas is up next with cultural resources. Are you on the line?
Yes, I am. I believe I'm going to share this with Abby Cadman, who's going to start off with that. So if Abby is there, you could take over and start the slides.
Okay, so good morning, everyone. I'm just jumping in here for a few slides. Going to share some important but less interesting information than Dr. Bellantoni will be sharing. So as you said, now we're changing to cultural resources. So that's one of the more interesting parts of our jobs because we get to experience going out to so many different sites and seeing the different historic sites that you can see in the woods, from the stone walls through foundations, and cultural resources is just an exciting aspect of it. But I'm going to cover some of the background, important stuff that we have as far as compliance. So essentially, I wanted to include some references on the background as far as the legalese and our requirements to evaluate cultural resources for our programs. So it's in a general manual, so it's a requirement. General Manual Title 420, Part 401 covers cultural resources, and the National Historic Preservation Act and Section 106 requirements. So it's broken down into a bunch of different sections. So 401.21 is just an overall considering cultural resources in an NRCS program. Then it goes into adverse effects. So we have to make sure that anything that we're planning, we evaluate to ensure that we're not going to have adverse effects on cultural resources or historic properties. Then there's a process. Every state has a process in place for doing this evaluation. So then from there, it goes into withdrawal of NRCS assistance. So if there's absolutely no way that the producer is willing to manage what they have planned for and be respectful of cultural resources, then we have every right to walk away. Then it goes into post-review discovery. So if you have gone through all the review processes and nothing has come up that needs to be considered, but you still need to be on the lookout and be ready to contact anyone as needed if you discover anything that could be considered cultural resources. So that's something every state has a policy in place. So then the next section it goes into is emergency work. And sometimes, for EWP and other programs like that, we have to do emergency work. There are provisions for who you need to contact and the process that you need to go through if you come across anything while you're doing emergency work. We have requirements for training. So every state has requirements for training people who are out in the field. And there's ag learn courses, and then there's a whole module and order of classes that people need to take. And then there's more sections, but then 401.30 is compliance documentation and reporting cultural resources and reporting that you do the review process properly. So at the bottom of that screen, I have the National Instruction 19310, which is the NRCS Statement on CPA program activities with no potential to cause effects to historic properties. So essentially, I encourage everyone to read all of these and become familiar with our manual and our requirements. But so for this one, if we're out there creating a CTA plan with producers, our requirement is that we need to make sure they're aware of potential impacts to cultural resources and historic properties. But if we are not actually saying exactly where something needs to go, we don't need to go through a full review process. So every state has their own requirements, but this national instruction gives us an overview on those requirements. All right, so next, just a few items of what's required for NRCS planning. As I listed before, familiarity with national policies, and then also follow any of the state cultural resources policies. So states should have PPA or programmatic agreement, any other agreements that they may have in place, and your state NRCS requirements. And these should also cover any practices that need further review or practices that are excluded. So these are essentially considered ground disturbing practices, potentially ground disturbing practices, or non-ground disturbing practices. So then another thing that needs to be considered is respect for time frames. We have to work with a lot of different partners, and they have a lot of things on their plate. So there's likely written into any agreement time period for evaluation where you need to be working with people to provide them sufficient time for them to respond to any evaluation. Like if you have to have something further reviewed by the state, there's certain time frames that they're allowed to be able to respond and before you can move ahead with it. So those are things to keep in mind, as well as for any partners you're working with. And then it's our responsibility to make sure that the client understands that since this is federal money, there is a cultural resource review process that needs to go through for any potentially ground disturbing or ground disturbing practices. And then also any additional requirements during the planning process, be it from the review process or just discoveries after review. So since it's federal money, we have the responsibility to make sure the client understands that there are these processes we need to go through. And then also in our planning, we oftentimes have a requirement that there's monitoring by NRCS or an archaeologist during implementation. So you need to be aware of that for when those practices come up for installation. So just need to stay on top of that. And then oftentimes, if a plan changes, then additional or new review is needed. So just to be aware of that. So if you've had your practices reviewed for one location, but they get moved to a completely different field or the installation is in a completely different way, then that needs to be, probably needs to be re-reviewed, and the whole time frame needs to be considered too. So the official place where we document this is on the NRCS CPA 52, the Environmental Evaluation Worksheet, and under Section G, which covers the NEPA policy and special environmental concerns. I just wanted to point out that on there in very small letters, it says note items with a dot may require a federal permit or consultation coordination between the lead agency and another government agency. So that's a reminder that likely for cultural resources, we need to also be talking with our state partners or tribal partners, just depending on where it is and what it is. So just looking at the CPA 52 section, there's the benchmark conditions, which are what the site conditions are currently. So you document what the site conditions are for where we're planning practices. And then as you're going over into J, there's no action. So what would happen to the site if there were no practices installed? And then alternatives like 1 or 2 is where you would identify the planned practices. So as far as documenting the planned practices, you'd be documenting all the planned ground disturbing practices or practices that would potentially impact cultural resources, as well as any practices that would not potentially impact cultural resources. And then you'd also need to identify how those practices were determined to be ground disturbing or not through the PPA, the state agreement, or other resources. So however it was done, so partners that were consulted, and the dates of determinations and consultations, and what they required, if they required additional follow-up, any monitoring, changes to the plan, or whatnot. So, and then also in the 52 is a guide sheet. Every state has different requirements for using the guide sheet. I highly recommend using it, particularly for the cultural resources review, because it has very clear step-by-step guidance to determine what review is needed and when. So it walks you sort of like a choose your own adventure through the level of control. So if it's a CTA plan, then that's handled differently versus one where there's NRCS funding. So is the action an undertaking? Are we funding practices that are ground disturbing or not ground disturbing? And then also you have to consider the area of potential effect. So it's not just where we're planning the practices, but if there's any electrical or gas lines that are going to the practices that we're planning, or if there's borrow areas where we have told the producer that you can take some gravel out of this part of their property to move it to where we're installing a practice, that's something that needs to be included in the review. And also if they found any artifacts on the site. So Meredith and Debbie had said the producer knows their property better than anybody else. So it's always good to ask them if, they've found any artifacts. And then we also have to document if we've checked all the required records, like the state and national registers. So those need to be reviewed. And then also a consideration if the proposed actions can be modified and have all required parties been consulted. And also, have all required forms been sent out and is a review complete? And then there's also a notes box for additional comments. So just wanted to cover the important required background that we need to evaluate and have it set up so I can't see if there's any questions or not.
There are not questions at this time, Abby. Thank you.
Okay. All right, thanks. Well, then I guess we shall switch to Dr. Bellantoni's presentation. So we are lucky to have Dr. Nick Bellantoni, who's the Emeritus Connecticut State Archaeologist. He got to be the Connecticut State Archaeologist a couple of times. He's a very enthusiastic field person. He's an author, just an overall excellent person, and he can tell you absolutely everything about Connecticut that you had no idea was out there. So hopefully Nick is on and ready to take it away, and I will change slides as needed.
Great. Thank you, Abby, and good morning, everyone. This discussion about not only cultural resources, but also soils. And what I'm going to do is give you a series of in the soils, how we work as archaeologists, but what you could look for when you're out on projects. You might be confronted with gullies that expose soil and so forth. The issue would be, how do you determine, or how can you at least recognize to alert if there's a significant cultural resource? So, Abby, give me when I'm ready for one. Here we go. We work in the ground as archaeologists. We work in soils. So having at least a working knowledge of soils becomes very important to us. Because basically here in the Northeast, especially and anywhere east of the Mississippi, where you had the forest environment, the biome, soils build up, and as a result, history and archaeological sites get buried. And so the combination of artifacts, like you see here, in terms of what we do as archaeologists, we're not just collecting artifacts. What we're trying to do is interpret past cultures. And some things are going to be easy for you to recognize: stone walls, modifications of old structures. Well, sometimes what's in the ground is not as clear cut. Give me the next one. So next slide. So basically what we're looking for are concentrations of past materials, artifacts, features that are important. Artifacts you all know about. They're tangible things. Sometimes they're called arrow points, pottery, and so forth. But features are sometimes stains in the soil that are indicative of human activity in the past. And that's what we're trying to understand within an archaeological context. Next slide. So some of the stuff is very shallow in the ground, depending on soil buildup in various parts of the country. In the American Southwest, in the desert, there's almost no soil buildup other than erosion and movement of soils. And you could find artifacts and features on the ground as you walk over it. And even here in the Northeast, where sites are buried, are fairly shallow. So they could be hit by a plow. Artifacts you're familiar with. They're cultural manifestations of our behavior. Next slide. But it's stains in the ground that I'm concerned about for you in terms of this. So here you see is a circular stain with shell coming out of it. And basically what that is a refuse heap. It's garbage being dumped probably off of a village or campsite that may accumulate in certain deposits. You can see the soil around it is natural, but that darkened stain turns out to be the refuse pit, and it's full of foodstuffs of ancient peoples, in this case, much shell along the coast. Next slide. So we go into the ground as you do, maybe not trying to record nutrients, but looking for stains that might be indicative. Anthropogenic soils that might be indicative of past human activity. Next slide. Next slide. There you go. And here's those of you along the coast will have shell middens to deal with. Here's a Native American wigwam. This is a house structure that would have been there for thousands of years here in eastern North America. And while we can't see those today, we can actually find them through soil stains. Give me the next slide. You can see the interior one. Next slide. They were made by posts that are secured into the ground. But everywhere those posts go in the ground, next slide, when those decay and decompose, they leave a soil shadow. So if you look into that test pit, you'll see that circular soil. What that is a post mold from a wigwam structure. If you can open up next slide, the area, you could certainly see a pattern of these stains that are indicative of the actual house structure. As archaeologists, we can excavate inside the house, we can excavate outside the house. So sometimes even just a circular stain, it could be a gopher hole, it could be a root shadow. Those all could be, natural, but they could also be because of a post stuck in the ground to create a house. Next slide. So we get to know and understand the soils around that are helpful. The fireplace you could see here will leave charcoal stains in the soil that allow us to get radiocarbon dates and actually date the structure and the archaeological site. Next slide. And what you're looking at here, these mottled stains in the ground, that mottled stain, that's kind of a prehistoric refrigerator. It's basically where native peoples would dig a hole in the ground, use the soil, the earth, as a means of preserving food and layering it in the ground, covering it over so that we get roots, nuts, seeds, corn product that are housed in here. The soil keeps it cooler in the summer, it keeps it warmer in the winter, and it allows for storage for specific areas of time. Next slide. So those are all very important to us. This is one of my colleagues who has studied the Pequot War at the Pasture System Pequot Reservation, Dr. Kevin McBride. I just point him out, next slide, because doing an archaeological survey on the Pequot Reservation, they found, if you could look at that excavation, a dark linear stain in the soil. And at first they were totally confused as to what that was. Next slide. When they expanded the area, you could see that dark stain coming to almost a triangle. Next slide. Mapping it out, it shows the remnants of actually a bastion, a corner of a historic 17th century fort. Next slide. And you can see the outline of the fort here. Inside the excavations revealed wigwams and foundries where metal was being cast. Next slide. And basically what we found from a stain in the soil was the remnants of a fort that was built during King Philip's War here in New England in 1676 that protected Connecticut from attack from the Narragansett Indians in Rhode Island to the east. There were no historic records of this fort other than one line. So it was found because of a stain. Burials may be uncovered and on farms simply because, and here in New England especially, farmers buried their dead in the backyards in some cases. So this schematic shows this kind of, on the top, a natural soil profile, an excavation to bury someone, and the refilling of soil inside it. What that leads is to a completely disturbed context that is very definable. Next slide. You could see it here in terms of excavating down to a burial. You could see in the center the changes in soil from, on the far right, a very sandy, clear soil, to mixed mottled soils. You could even see the hexagonal coffin, where the sideboards of the coffin have now decomposed, but leave a soil shadow. So those are very important for us to define in terms of where burials might be. Sometimes they come up simply because of a stain in the soil. And these are these are found through geophysical techniques sometimes as ground penetrating radar and other characteristics. Next slide. Here's kind of a horizontal picture. You can see the rectangular cut of the burial shaft. again, allowing us to define these things based on anthropogenic soils. Next slide. And we sometimes use soil cores and probes, but many times working with NRCS, we can use ground-penetrating radar to help us find where cemeteries might be located. Be careful with probes and cores because they could disturb cultural resources in the ground, but they become very important mixtures. Next slide. And also look for soil compaction. Wherever digging has occurred and been refilled, obviously the soil is less settled. There are, the soil compaction is airier, and there's sometimes depressions form, small cracks around the edges that come into view. We could find them sometimes very subtly, only a couple of centimeters, but there's a gradual sloping toward the center that allows for us to define these things right from the surface, along with excavation and testing of those areas. Next slide. Next slide. And so just to close with this one, this is a midden trench. This actually from an excavation in Norwich, Connecticut, is from an old tavern, and basically the back of the tavern they would just dump the trash and foodstuffs and so forth. You could see the lower levels have a lot of stone in it, and the upper levels you could see various levels of shell and garbage that has been totally buried. So these things are in the ground. They're not natural. They are anthropogenic, and they tell tremendous stories of the past and how humans have developed and worked on it. Farms are extremely important to us because there's only minimal or moderate disturbances. So many of them house very significant archaeological sites in the soils underneath them. Any questions?
It looks like we have.
Yep.
Oh, can you see it, or would you like me to read it?
Yeah, what are important in the planning process is to get someone out there that's knowledgeable in cultural resources and what to look for in the soils. We assist NRCS here in Connecticut in doing so. You want to look for, if the soils have been tilled, you might see artifacts on the surface that have been brought out. If there's any gullies or erosion, sometimes we'll expose features that could be, of archaeological significance. What I would say to you is, we don't expect you to be archaeologists and be able to recognize this, but be sure within the cultural resource process of your state, you have somebody that can come in that is knowledgeable to assist if there's any questions about, archaeological features. But you are likely to encounter them, even though you may not see them on the surface.
Great, thank you. That looks like the only question.
Great.
Thank you for your presentation. It looks like, we have a late to the game question here. That's a little bit too big for me to show the whole thing.
Well, the answer to this question here about, it would be if there's an NRCS undertaking to know that they have found arrowheads, for example, on a farm would be very important in defining where on the property they are coming to. You wouldn't have to stop gardening at all. That's already a moderate disturbance. In fact, the gardening has helped us find the site. What we would be interested in is the potential underneath in the subsoils for potential deeper buried features and other things. But no, don't stop the gardening. Support it, but if there were to be deeper disturbances, maybe then we would want to be able to get in there and do some further testing. And how common are these? My goodness, there are archaeological sites all over New England and all over the country. People have lived here for, at least in New England since the glaciers have left. And as the oldest site we have in Connecticut is 12,000 years plus old. And literally native peoples and have utilized the land extensively through thousands of years. Look for wetlands, look for well-drained soils that might be residing to it or by it. And historically, you're going to see, you know, remnants of old farms that might be helpful. Have you lost me?
I have
No,
not.
you're there.
I just saw the sign that lost. Oh, Cynthia lost connection. Okay, I thought maybe I was missing it. But the point is, no, there are archaeological sites everywhere. There are certain landscapes, topography, soil types, wetland proximities to wetland, especially, that we can key into as having high potentials and high sensitivity, and that's what we try to key out. It may not be the entire farm, it may not be the entire pasture, but areas of well-drained soils near wetlands could have that definite high potential.
So let's give another thank you to all of our presenters today. I know they can't hear you because you're all muted, but we do appreciate your presentations. They've been very informative today. So thank you all, and we'll see you tomorrow.